Hi there, and thanks for watching. If you like the content of this video, please like and subscribe. For this course, you'll need Visual Studio Code, which is a free code editor you can get online. It's really very useful and I highly recommend it. It's very useful for JavaScript programming. So let me give you some of the basics of what you're going to be doing with Visual Studio Code so that you're ready to start the lessons. Alright, on the left hand side of the screen is going to be essentially a folder. So right now I have a folder called Lesson 1 Variables, right? So that's a folder, and then these are the files inside that folder. So basically Visual Studio Code is organized with folders. So you can open a folder by doing File, Open Folder. And I suggest that you have like one folder that is for coding, so as we go through examples, you're typing along and saving the examples in your own computer. You'll see that there's files here. JavaScript files end in .js. So to make a new JavaScript file, all you have to do is hit this plus button here where there's like a file. This is for folders. This is for just single files. And then you can start typing in the name of a file. So for example, new file, .js. And then notice that this JS is in yellow next to the file name, and then it will open up a tab, and then there you go. You can start writing your JavaScript code literally in this editor right here. Alright, so Visual Studio Code is already set up to deal with JavaScript, which is great. We like that. As far as extensions, there is a tab for extensions here. It looks like these like 3 blocks for this other block. I use an extension called Prettier for my code. That's why my text might look a little bit different from yours in terms of color. If you'd like to get an extension, it's pretty easy. You just have to type in the name of the extension. Like for example, if I type in Prettier, and then usually look for this like check mark, because there's usually a lot of like posers, like people who pretend to be a famous library to get clicks, so don't fall for that. Prettier code formatter, prettier.io. You can use this if you'd like. It's an extension I use. So again, if your Visual Studio Code, when you're typing, if the color of the file looks different, or like when I'm typing something it looks different, that might be the reason why. If you like the extension, go ahead and use it. Otherwise, it's fine. It doesn't matter if you have it or not in terms of whether or not the JavaScript will run. The other thing I use is Node. So what you can do is in Visual Studio Code, you can open up a terminal by going to Terminal and doing New Terminal. And this terminal is no different than doing like CMD. All right, so it's just basically a terminal that is inside Visual Studio Code, so that we don't have to have a separate terminal. So normally you do like CMD for command prompt, and then it would be open, and that would be kind of a hassle to have to go back and forth between this and Visual Studio Code, so someone was nice enough to just put it in here for us. To run a JavaScript file using Node is very simple. You're just going to do node, and then the name of the file, so like node basics of variables.js. Alright, so again, the command is node and basics of variables.js. If you get a weird thing saying like node is not recognized, you need to go download node and install it. Alright, so just go ahead and Google install Node, and you'll easily find the website where you install it from. Be sure that is installed because I like to use Node. It's faster to run things in the console, so you'll see me do like Node and then the name of the file, whatever it is, .js. Alright, and that will run the file so that you can immediately see the results in the console. Alright, so hopefully you've got Visual Studio Code downloaded and installed, you've got Node downloaded and installed, and you've done a little bit of practice with making new files and maybe got yourself a few extensions, right? Then you're all set to start the lessons. Compared to a lot of other programming languages, JavaScript is fairly straightforward when it comes to variables. There are certain types of variables. When I say the word type, I mean like category of variable or kind of data. So I don't mean like typing on a keyboard. Alright, so JavaScript has, these are the types, okay, and if you have an interview, I would actually recommend to go so far as to memorize these, because they might ask you in an interview as sort of just making sure you know about the basics of JavaScript. Alright, the types of variables you can have in JavaScript are number, string, boolean, null, undefined, big int, and symbol. Alright, these are the 7 basic variety of variable in JavaScript. I put them in order of what I find to be the most useful. Alright, so number, string, and boolean, they're going to come up all the time. You're going to have to really be good with these in order to be able to program effectively in JavaScript. Null and undefined are also huge. They come up all the time. Big int will come up sometimes, and I will be honest with you, I've never used symbol in my life. Symbol only occurs in very, very niche situations, but you should be aware that it exists. Alright, now number is exactly what it sounds like. So in JavaScript, in order to create a variable, we use the word let, and then we give the variable a name. And one of the biggest beginner mistakes is that they think that the name of the variable has some special meaning to the computer. It has meaning to us, but it has no meaning to the computer other than it's just the name we give it. So you could just as well call it potato. All right. Then you have equals, and then you have a value. Okay, and that value will determine what kind of variable you're dealing with. So for example, any kind of number is going to be the number type. So I have let age equals 20 here. All right, so let age equals 20. All right, and you can put an irrational number here too, or a fractional number, or an integer. It doesn't really matter. Other programming languages care about that kind of thing, but in JavaScript, they all roll into one big category of just numbers, right? So any kind of number you want to put here, 20.5, 20.112, or whatever. If you want to put like pi here, whatever you feel like, okay? It's just a number, right? So any number will fit into that category. Now, for things that are not numbers, for like example, people's names, names of cities, those would be strings, right? We denote a string with quotation marks. Now, you can use double quotation marks or you can use single quotation marks to indicate that something is a string in JavaScript. They're both okay. I recommend being consistent. So if you're going to use double quotes, use double quotes all the way through your program, or single quotes. That way it just looks a bit better. It's easier for you to read your code and understand which things are strings. So just be consistent, but you can pick either one. All right, and again, as you see on line 4, it says let name equal, and I use quotes to indicate it's a string, and I put Jordan Smith inside. And you can put letters, you can put numbers, you can put symbols. All right, it's a string. So you might be thinking, okay, well, could we do 20 in here? You could. It's not going to be treated like the number 20. It's going to be treated like someone wrote down 20 on like maybe a napkin or something to that effect. All right, so you can think of a string as like when you want to name things. That's a really good way of thinking about it. All right, next we have Boolean. Okay, let is student equals true. All right, so Booleans come in two varieties, true or false. You're going to write the word true, or you're going to write the word false. Pretty straightforward. Booleans have two values. They're on, you can think of like an on or off switch. Okay, they're either true or they're false. It's off or it's on. It's inside or it's outside. Anytime you have a situation where it's only one of two choices, and the Boolean is a good candidate to use for a variable. All right, now we have big int. Okay, big int is for giganto numbers or super small numbers. So we're talking like number of stars in the universe, or number of atoms in the known galaxy, or something ridiculously small or ridiculously huge. All right, so in this case, I use this term big int and then parentheses, and I put my huge giganto number inside. All right, and again, like you could do this for 20 or something, but big int is really for things that lie like really, really huge numbers. All right, again, you may not necessarily come into a real life situation where you have to use this all that much. That's why I kind of put it towards the end as far as like in the list up here as to usefulness. Like it does come up, but again, like you're going to be using number 99% of the time in your daily programming life. Now, null and undefined are kind of weird to explain to beginners because they're conceptually and philosophically really weird. But null is essentially, it does not exist. All right, it is nothingness, void. All right, so I have like let Lions fans equal null. I'm from Detroit. If you know our local football team, you know that anyone who has had any hope has already left them behind a long time ago. So Lions fans equals null. They're non-existent. All right. That isn't opposed to undefined, which means null represents like lack of a value, like it doesn't exist. Whereas undefined basically means we haven't set it yet. There's actually a really good infographic I use to kind of display the difference between these things, and I don't know who the author is, but you can think of it like this. So example, we have a non-zero value, which means there's some toilet paper on the roll. 0 means we've used it all, there's just a roll left. Null means the toilet paper roll doesn't even exist, and undefined is we haven't even set it yet. Like no one's actually defined anything in here, all right? So if you don't totally get that as a beginner, I totally understand. It takes a while to get the difference between the two because one is like, this is basically to say like the absence of something. It's a way for us to actually like write that something isn't there, and that comes up a lot later when we start doing more complicated programming where this will be a thing. And then undefined basically says we haven't actually set it yet. Like we might set it later, maybe, but it has not been set yet. All right, so these two as a beginner are very difficult to like get off the bat, and it'll take some practice before you get it. So if you don't get that off the bat, that's fine. Symbol, I have an example of symbol at the bottom. Again, I've never used symbol, but you can put a string inside symbol to make it 1. You can play around with this a bit. I really would not spend too much time with symbol. I would really try to master the other 6. Okay, so number, string, boolean, null, undefined, and big int. Those are the ones I would spend my time trying to learn. All right, again, to review, we have let is our way of declaring like, hey, we're about to do a variable. Then we have a name of the variable, which again could be whatever we want. Okay, equals, and then we have a value, and the value will determine what the type of variable it is. JavaScript will say, okay, cool, you said age is 20, so therefore age is a number. Then we have strings. Strings are denoted by quotes, either single quote or double quotes. If you want to do single quotes, you can. If you want to do double quotes, you can. They're both perfectly fine. All right. Let name equals Jordan Smith. Then we have booleans, which is false or true. So any sort of off and on situation where it's either true or false, either or. Big int is for huge, like really huge or really small numbers. Null is a representation of something that doesn't exist. Okay, it says non-existent. Undefined means it's not set. All right, and these are the basic types of variables in JavaScript. All right, let's continue learning about variables in JavaScript. All right, so again, I'm going to make a new file. I'm going to hit this new file button right here, and I'm just going to call it constant variables.js. Right, I'll open up a new pane that can begin my coding. I've already got my terminal open. If you don't remember how to open your terminal, go up to terminal and do new terminal. Or you can do Control-Shift backtick. Backtick is a weird key you probably don't use ever. It's the tilde next to like the left of the one on your keyboard. All right, so last time we learned about the let keyword. Okay, we did like let full name equals Jonathan. Okay, for example. All right, so let means we're about to create a variable. Then we have the name of the variable and the value of the variable. Like what information does this variable hold? Remember, variables like buckets, they hold information. Now, sometimes we like variables that change because, you know, like let's say we're give someone a form. I'm sure you filled out a form online asking for like your name and your username and your password. Okay, that stuff changes from person to person. However, sometimes we would really like a variable to just be set in stone. Okay, so like we don't want anyone to be able to change the variable. If we use let, then I can go ahead and change the value of full name to something else. Okay, so for example, on line 3, I change the value to Bob, and JavaScript will run this, and there will be absolutely no problem. Sometimes you may want to not allow yourself to change the value of a variable, so we're going to learn a different keyword today, which is const, C-O-N-S-T. So it's the same basic structure as let. So you have const go first, and then you have the name of your variable. Let's say it is product key is equal to, and you'll typically see like maybe it's some sort of like internal password. Okay, and you've seen those like really crazy passwords in those password managers. So you'll notice it's got like some crazy symbols and some letters. Let's say this is our product key, and we don't want this to change. It's the key for the products. It's not going, like, this is it. This is the internal password for our system. It's not changing. I don't want someone to overwrite this. So you can use the const keyword. Now product key is going to be constant. It will always be this value from here on out. So you're saying, well, Jonathan, I just type this, right? Everything should be fine. So let's go ahead and look at some things. First, I'm going to console log product key to make certain, kind of show you that it holds the value just like let does. And then we're going to try to change the value on line 5. So let's kind of run this. We're going to do node constant variables, okay, to run it. And oh my God, we're getting an error. Let's go up and read the error. One of the things I always tell my beginners is to, I know you don't, this is new, and errors are scary, and they're filled with a bunch of gobbledygook. I do want you to make an attempt at reading the error, because learning to read the errors will let you know what's wrong. The computer doesn't lie. So, what's the computer telling us? It says, okay, cool. It points to where the problem is. You see how line 5 and this are the same? So it's pointing, it's a little arrow pointing to it where the problem is. And basically what this error comes up because we tried to change the value of a constant variable. Product key is constant. You can't change it. Okay. After line 1, you cannot make this into anything else. It is constant. It is unchanging. So constant variables are great because I know for the rest of my entire program, I can write 1,000 lines of code. This variable with the name of product key will always have this value. Okay, no one is allowed to change it. So constants are usually, for like product keys or like things that get set at the beginning and you don't want other people to touch them. All right. Other kinds of variables like let are for things that might change over time. So for example, let's say like player score. Okay, that might change over time, right? So, but for example, a thing like a product key or configuration settings, those sorts of things tend to be constant because like once they're set, they're set. You don't change them afterwards. So you as a programmer get to decide when you're making your variables, is this variable something that's going to change over time? Or do I want this variable to be set for the rest of time? With JavaScript, you have that power. Okay, you can choose let or const when making a variable, and then it will stick to the rule. And if anyone tries to change the value, they'll get an error just like something like this, okay, with an arrow pointing straight to what the problem is, right? So that is a way, and we as programmers can have some control over what we're programming. Okay, we've been doing the basis of variables. Now let's talk about variable types in the next lesson. Now, some of you who already know a little bit about JavaScript may notice that I introduced let and const, but I did not introduce var. So there's this other keyword called var, which we also can use to declare variables. So for example, var full name equals Jonathan Hop. So this would work and your program would run, and I would recommend against using var. The practice nowadays for JavaScript programmers is to use the keywords let or const. So let or const, like we just learned. Var will do the job. It will make the variable that will hold a value. I'm not saying it doesn't work. I'm just saying that var can get you into a lot of weird situations when you get to be more advanced in JavaScript. But let and const will work just the way you think that they do. So early in our JavaScript career, it's going to be very difficult for me to explain to you clearly why it is var is not so great. But for right now, the thing I would say is we're not going to use var at all. I'm going to use let or const, and I'm going to just basically let you know that var exists, but you shouldn't use it. Like, get in the habit of using let or const when programming in JavaScript. Var is one of those things that is still around because they can't get rid of it because JavaScript is too entrenched in the internet. I do want you to know it exists, but when we declare variables, I'm always going to use let or const, and I think you should too. Okay, it will make your programming experience much smoother as you grow stronger in JavaScript. A common interview question that might pop up with respect to variables is about JavaScript being a dynamically typed language, unlike, say, Java or C#. What does that mean? Well, it's pretty simple. So far we've done variables, and I can do, for example, let some number equals 10, all right? And so we get that. But I can take the same variable, let's say I'm going to const log it actually first, some number, okay? And then I'm going to do some number is equal to Bob Smith. All right, and I'm going to console.log some number again. I'm going to run my program and see what happens. All right, so I'm going to go here, I'm going to make sure it's saved, and I'm going to do node interview question.js. All right, and then my program ran without any errors. It said 10 and then Bob Smith. So this variable some number, first it held the value 10, and then on line 5, I switched the value. It used to be 10, but now it's a string. It's a string, so I'm using these quotation marks. And notice how my program ran. There were no errors. This would not be possible in other languages necessarily. So for example, if we were using C# or Java, you could not do this. In statically typed languages, once you declare a variable as a certain type, it stays that way. In JavaScript, it is dynamically typed, meaning that essentially as we run our program, it will figure out what some number is based on what you set it equal to. So on line 1, JavaScript says, okay, well, you set this variable some number to 10, so that therefore must mean that this is a number. And then on line 5, it's like, oh, you switched it to a string. Well, that's cool. I'll just keep on running. All right, so that is one of the big differences between, say, JavaScript and C# and Java. All right, so in C# and Java, once you declare something a string, that's it. It's a string for the rest of time. and your program will not run if you try to do something like this. Whereas in JavaScript, it's fine. The variable is whatever type you say it is, and the program just keeps on moving. Right? The other big difference that they might ask you between JavaScript and some other languages is that JavaScript is interpreted. What that means is the program just starts at line 1 and just starts running. All right? You don't have to like compile or build your code in order for it to run. In languages like Java or C#, you would have to build your code, which means taking your code and turning it into ones and zeros and making a nice little exe and then running it. Right? JavaScript, we just basically take Node or we take the browser and then it just basically starts at line 1 and reads, line by line till the program stops or JavaScript reaches an error. All right, so that is a difference between JavaScript and some other programming languages, which might come up as an interview question. All right, let's work with numbers in JavaScript. And working with numbers is actually pretty straightforward. It's just learning the symbols for them. So if we go back, remember we talked about types. Okay, variables had types. So one of them was number. So for example, I could be like, let age equals 50, right? So age is the variable. Okay, so the name of the variable is age and its type is number. Okay, I'm going to make certain we drill this word type into your head. A lot of beginners try to just gloss over it, but it's really important to understand this concept. All right, so we need to work with numbers, right? What I mean by that is, having a variable hold a number is all well and good. But think about like if you're going to a store, right, and they start ringing up your items. Well, we have to add the price of those items together, right? Because you have eggs and milk and whatever else, and they each have a price, and then we have to put all those prices together. So we need to do arithmetic, typically speaking, with numbers. Okay, there's other things we can do, but let's start off with basic arithmetic. So for example, plus would be for addition. So we can even add numbers together. So let's use the grocery example. So I'm going to do let price of eggs equals, let's say, $2.99. Okay, I'm going to let price of milk equals $1.99. All right, well, let's add them together. Okay, let total equal price of eggs. You see how IntelliSense is picking up the variables, so I can just hit tab. So I don't have to type all that out. And then you can add them, plus price of milk. We could even use what we learned in the previous lecture about strings to make a cool little message. Console.log. Okay, and then we're going to use string like this and say your total is, put a little bit of space in between here, then plus, and then total. All right, so that way we can see like, hey, you got some eggs, you got some milk, and we can add those together. All right, so let's make sure we save with Control S or use File, Save. All right, and then let's go ahead and run this. Node, working with numbers. Okay, you can name your files whatever you want, but you're probably going to want to stick with what I'm doing, so I call this file working with numbers. Okay, your total is 498. All right, so addition is just a plus sign, right? Now, we can use multiplication, okay, which is a star. So we can do like maybe like a subtotal. Like, so for example, you have two eggs. So let cost of 2 eggs equals price of eggs times, which is a star. Let's say we got 2 eggs, 2 packages of eggs. So the star is multiplication. Okay. So we can go ahead and put out a message. The cost of 2 eggs is, and then plus cost of 2 eggs. All right, save, and then cool thing you can do on your terminal is you can hit the up arrow when you've already put in a command, so you don't have to type it out again. I hit up, you see how it filled in node working with numbers, so I don't have to do all that the second time. All right, and as you can see, we did multiplication. So this star is how you do multiplication, right? Let's do subtraction. Okay, so we could do, let's say the person doesn't want one of their eggs anymore, right? They're just like, okay, I'll take it back. So let's say discount is equal to, well, yeah, let's do that. And then do like $2.99 for eggs. And let's say you had like a coupon for $1 minus 1. Okay, so you use minus for subtraction And then the last one we can do is, for example, let average grocery cost. So we have like that total, right, on line 6. So we do total divided by, we had like two things. So divided by is this slash right here, right? So let's review. Addition is the plus sign. Multiplication is a star. Subtraction is minus. And division is a slash. Okay, and after that, you can do what you want. You can do multiple things. You can go crazy. You can tie a lot of things together, like let crazy equation equals 5 times 6 plus 80 minus 10 divided by 6. You can do as many of these in a row as you want, all right? As long as you remember the symbols for working with numbers, right, then you'll be able to do pretty much any arithmetic operation you need to. And notice another thing is that I'm using these variables, okay, to do my calculations. You can do it with numbers just like this, or you can do it with variables, okay, which hold the value of those numbers. So now you're able to do a lot of the basic things you'll need to do with JavaScript in order to do math. So for example, if you were writing an app that is a shopping app, you'll be able to add items together, multiply an item by its quantity, divide items, maybe getting like an average. All those things that you'll need math to do, you now know how to do. Remember, we use plus for addition, star for multiplication, okay, minus for subtraction, and then this slash for division. Okay, once you got that down, you'll be able to do all of the basic things you'll need to do with numbers. We're going to go over a very confusing but very useful function to check to see whether or not things are numbers. So it is NaN, which is, and then parentheses, and it is a function. So this stands for is not a number. The reason I find this a little bit awkward is because, well, we'll look in a second. I'm going to console.log is NaN, and inside the parentheses, I'm going to put 27. So 27 is a number, clearly, right? So we're going to console log this and see what it gives us. Okay, it gave us false. What does that mean? What that basically means is that 27 is a number. All right, so that means that, okay, cool. So is not a number is because the way it is written with a negative. You would think that, like, some people make the mistake of thinking it should return true. It's not. Is it a number? It's not a number, right? That's what makes it a little bit awkward. So since 27 is a number, then this returns false, meaning that false basically means that the thing you're putting inside the parentheses is a number. Now, let's see what happens if we try to make this a string. So I'm going to put a string of 27, all right? And I say it's a string because of these quotation marks. Now we'll see what it gives. Okay, so I'm going to write it again. We got false. Why? This is a string, right? Okay, JavaScript has this idea called coercion. What that basically means is that JavaScript's going to say, hey, you didn't give me a number like I expected, right? But I'm going to try to take the thing you gave me and convert it to a number. So behind the scenes, and again, you don't see this happening, but JavaScript does it for you, that 27 can be turned to a number if you just take it out of the string and make it to a number. All right, so this 27 here, it's coercible to a number, meaning that if you wanted to convert it to a number, you could. You're like, okay, Jonathan, that makes sense. Now, here's something that could not be converted to a number. All right, dog. Okay, so like a dog, there is no number dog. Like, you can't take dog and convert it to a number on the number line. It just won't work. All right, so let's run this and see what we get. So is NaN dog true? Okay, meaning it's not a number. All right, so it's not a number is true. So that means that this dog cannot be converted into a number. Right, so this is a great way of checking to see whether or not something is a number, whether or not you directly give it the number, or maybe you give it a number inside of a string. Okay, then you can also check to see, like, hey, if I convert this to can I convert this to a number? Can I coerce this value into a number? All right, so you might be thinking, what about Booleans, true and false? All right, this might be a little bit counterintuitive, but let's give this a shot. So Boolean, I put true, which is a Boolean, and then we're gonna run our program and see what it gives us, true or false. It gives us false. And you might be thinking, well, how does that work? Like, true is just a Boolean. How could true be able to be coerced into a number? Well, in JavaScript, 0 could also be thought of as false, and 1 as true. All right, so Booleans could be represented by numbers. All right, so if I try to take false and coerce it into a number, I'm going to get 0. If I take true and coerce it, meaning I magically change it into a number, I'm going to get 1. And 0 and 1 are common ways to represent Booleans, 0 being off, 1 being on. If you're familiar with binary, you would be familiar with this. So that means that if you try to do this with a Boolean, you're going to get false. Same thing if I put false in here. Okay, I'm going to save and run it again. All right, see, there you go. All right, now if I try to put, like, this in a string, though, like, let's say I put false, like, as a string, then as you can see, it's not going to take this string, turn it into a Boolean, and then turn it into a number. It's not going to do that. It's going to basically take this string and try to immediately turn it into a number, and there's nothing on the number line that's equivalent to false. Okay, but if you do the straight up Boolean, it will coerce the Boolean into a number, either 0 or 1. All right, so that is this function is not a number. It's a great way to check to see if something is a number or can be converted into a number. Let's do more with strings, because strings have a lot of built-in functionality in JavaScript that you might find really useful. All right, take this for example. I've got let lowercase string equals this is all lowercase. All right, so we've seen this before. We have a variable called lowercase string, and then we've got just the value. All right, what if we wanted to like change this to like uppercase? Let's say we wanted to like do like all caps kind of thing. So I'm going to do console.log, and I'm going to do lowercase string, which is the name of the variable, dot. And notice when I do this dot, I've got all these things that pop up in Visual Studio Code. This is called IntelliSense. And IntelliSense is sort of a way of letting us know, like, hey, you have these options. Here's some built-in functionality that JavaScript has at your disposal, and you can pick which thing you want to use. Eventually, you'll learn a lot of what these are. For right now, they may be like, what are these things? But you can think of them as sort of like pre-built functionality that goes with strings. Methods, all right, so we want to have all these methods, all right, that come with strings, and they do all sorts of cool stuff. For example, we're going to use to uppercase, all right, so we're going to do to uppercase, and then we're going to do two parentheses. So notice how my parentheses are like this pink, all right, that means that this is a method. A method is sort of like pre-built, it's like functionality, okay, that's the way I usually like to explain it. All right, so the fact I'm able to do dot to uppercase means that this lowercase string, like this variable right here, is a string, and therefore it has this to uppercase method. If I had a number, like let's say 10, and I try to do the same thing with the number, like some number dot, notice how there's no to uppercase, right? Like that doesn't make any sense. So it's going to go like this. It'll look yellow, all right, but then if I try to run this, I'm going to do node working with strings.js. It'll get an error, all right? It'll be some number dot to uppercase is not a function, all right? So that means that, hey, numbers don't have a to uppercase function, okay? Might use the term method and function interchangeably. In some programming languages, there's a difference, but in this one, there really isn't. You can think, if you like function, if you like method, take your pick. But basically, numbers don't have the to uppercase, okay? Strings do. This is why understanding the difference between types, the reason why I say the word type all the time, the reason I'm harping on about strings versus numbers versus Booleans, is that they all have a lot of pre-built functionality that's different from one another, and making sure you understand what type your variable is will help you to understand what you can and cannot do with those things. All right, so let's see what look to uppercase does. And I think you've already figured out what it does. All right, so I'm going to go ahead and save this and run it with Node working with strings.js. And as you can see, it takes something lowercase and makes it all uppercase, all right? So even if I had like a mix, like let's say I go through and I have like some of this is uppercase, some of it's lowercase. Okay, I'm just gonna mix it up right like this, right? Like someone is writing on a chat, in a chat board online. Okay, I'm gonna run it again. Okay, it doesn't matter, it takes everything and makes it uppercase. All right, there's another method, which is the opposite, which would be to lowercase. Okay, again, we need these parentheses to indicate that it is a function. All right, if you this will not work. You need the function to basically say, hey, do the functionality. So here, I'm going to replace this is all uppercase. All right, as if we're screaming on the message board, and then I'm going to run it. And notice how it takes all those uppercase letters and turns them into lowercase letters. All right, so these methods with strings, okay, these functions, is pre-built functionality that comes with the string. Like when you get the string off the showroom floor, all right, you take it for a test drive. This is functionality that you get. Okay, so lowercase does not exist for numbers, does not exist for booleans, it just exists for strings. And methods like this are very, very useful for us because we're going to work with strings a lot during our programming career, and you may want to format your string in a certain way. All right, we're going to be learning casting today, right? This is another piece of information we're going to need for our guessing game. So we already did if-else statements and all that good stuff, but what we need to do is we need to learn how to change strings to numbers and booleans and strings and all that good stuff. If that sounded confusing, let me kind of show you an example, and then I think it'll be pretty clear. So remember, in JavaScript we have booleans, strings, numbers. Okay, there's some other types too, but these are the big three, right? Remember we talked about variables way back when. So these are the types of variables, okay? So there's more, okay, but we're going to be dealing with these three today: booleans, strings, and numbers. To give you a quick refresher, use a let keyword and then give it a name. Okay, and remember, this name is not a magic name. The computer doesn't know it. This is not like special. Okay, you just came up with this. For example, I could name this Zebra if I felt like it. Okay, I just tend to go with names that make sense. Okay, but let's do 55. All right, so that means that this variable, the name is example number, and the value is 55. Okay, so the variable example numbers type is number. Okay, so this is a number. I could do let example string equals Jonathan. Okay, which means that the variable example string is of the type string. Type, remember, means like what kind of variable is it? There's different kinds of variables. There's different category of variables. Some of them are strings, some of them are numbers. All right, we'll do one more. Okay, let example boolean equal true, for example. Okay, so the type is boolean. Okay, so hopefully the concept of type should be a little more solid in your head now. One of the things we have to sometimes do is we have to switch from one type to another. Okay, so sometimes we need to take a value or some piece of data we get and change it from, let's say, for example, a string to a number, right? So what I'm going to do is I'm going to go down a little bit, okay, past my examples, and on line 12, I'm going to do let's make it a string number equals 1. All right, now you'll notice I put this in quotation marks. So you may think that the programming language doesn't really care that there's quotation marks, it just sees a 1. But remember, if I use quotation marks, that means that this is a string. It's not a number. So they're very different from one another. If I want to change this into a number, then JavaScript gives me a very convenient way of doing that. Okay, so first off, I'm going to teach you a new function called typeof. So for example, I'm going to do console.log typeof, typeof, parentheses, and then I'm going to put the variable inside. In this case, it's going to be string number. Okay, typeof tells you, well, what type of thing you have. So I'm going to go ahead and do node casting. Okay, it tells me it's a string. Okay, string number obviously is a string. Okay, but this typeof is very, very useful because it tells you what you're dealing with. Okay, cool. Let's say I wanted string number to be something different though. I don't want it to be a string anymore. Let's say I want it to be a number. That's very easy to do. I'm going to do string number equals number with a capital N, and then put the variable in there. Okay, number, and then put parentheses, and then put the variable inside the parentheses. So I'm changing the type of string number. So first it was a string as we saw in the console. Now when I save and run it, let's see what happens. It's a number now. Okay, this is called casting. Casting means taking a variable and changing it from one type to another type. And JavaScript makes it very easy to do because we get to, for example, we could take this variable string number and just all we have to do is type number and put the string number inside the parentheses, and then it changes type. Very, very convenient. And so you can, do 101 or 1510 or whatever number you want to do, and it will cast it. Now, Very cool. Another cool thing is you might be wondering, well, Jonathan, what happens if they put like zebra? Okay, obviously zebra cannot be turned into a number, right? There is no number zebra. So I'm going to go ahead and console log string number just so you can see what happens. Okay, so let me explain what's happening. Line 12, I said string number equals zebra. Zebra is not a number. I tried to cast zebra into a number. Let's see what it gives us. NaN, not a number. Okay, this stands for not a number. So basically what will happen is if you try to cast something that isn't a number, okay, it will just basically say, dude, this is not a number. I don't know what to do with it. Okay, it's the computer letting you know I couldn't do anything with this because I'm only used to dealing with numbers. All right, you can do also for Booleans. Okay, let's move down a little bit. I'm going to do let Boolean string equals true. Okay, this is a string. Okay, I'm also going to console.log type of Boolean string. And I want you to think about it a second. Pause the video and think about how would you turn Boolean string into a Boolean. Think about the way we did it on line 15 and see if you can figure it out. Once you thought about it for a second, unpause the video and I'll show you the answer. All right, we're going to do Boolean string is equal to Boolean, and then put the variable in there, right? So notice that there was a number, okay, and there's also Boolean. So let's go ahead and do that. I'm also going to comment out this console log, so that way we only can see the console logs for our example. Do the up arrow. Cool, it's a Boolean, okay? So it took true, the word true, the string true, and turned it into a Boolean. You can also do this with numbers. So, for example, 1 is true and 0 is false. I'm going to repeat that for Booleans. 0 is false, 1 is true. So, for example, if I do 1 and cast that as a Boolean, remember, 1's a number. Okay, I'm going to go ahead and get rid of this type of and just cast Boolean string and see what it gives us. It turned the 1, okay, took the 1, cast it as a Boolean, 1 is equivalent to true, and so it decided to show true. Okay, remember, 1 is true, 0 is false, because there's only 2 options. All right, so we are able now to change strings into numbers, strings into Booleans, numbers into Booleans. All right, this is great, because now I can do different things with different types of variables. So for example, if I do like some sort of mathematical stuff like adding and subtracting, I don't want to work with strings, I want to work with numbers. Okay, numbers you add and subtract them, not strings. Okay, so this will allow me to kind of go back and forth, and this will be very helpful for my guessing game, which I think we can get started on now. All right, let's do conditional statements. So the conditional statements allow us to have our program do different things under different circumstances. All right, so here is some code that's going to give us a random number between 1 and 10. Now, I know as beginners, your first instinct is to dissect every single piece of code and try to learn everything from it so you feel that you're not falling behind. Don't worry about this code. I'm giving you this code just as a means of showcasing conditional statements. All right, so don't worry too much about what each part is doing. You can just know that math.random is giving us a random number, and the rest of this is so that we can get a number between 1 and 10. All right, so to prove what this does, what I'm going to do is I'm going to console log random number. All right, remember the variable random number is going to be the result of all this stuff over here. And it's going to give us a number between 1 and 10. All right, now I have my terminal open. One fun thing you can do is if you're still having problems navigating using the terminal, that's fine. It'll take a couple more weeks of practice most likely. But if you would like a shortcut, you can right click on the folder and hit open in integrated terminal. And then bam, there you go. Your terminal will open up at the folder that you selected. So this is a nice shortcut. It can keep you from having to get confused or lost while trying to change directories. All right, so in the right directory, we're going to type node if then else. Okay, and I got 6. All right, so I'm going to try this a few times so you can see that it's giving me random numbers. Cool thing you can do with the command line is if you have already typed something in, if you'd like to type it in again, you can just hit up and it will fill it in for you. All right, so I got 1 that time. I got 9. So you can see it's giving me a bunch of random numbers. So that means that I'm not going to be able to predict what the value for random number, this variable here, I can't predict what this variable is actually going to, the value is going to be, because it's going to be different. All right, so let's go ahead and let's do some conditional statements. I want to, do different things based on what this random number is. In order to do that, we're going to use an if statement. All right, the if statement will show up in purple. You'll put some parentheses, and then we're going to put a condition inside of the parentheses. So like, if this is true, then do something. So basically the way it works is if some condition, then do something. Right, so look, for example, what if the number is greater than 5? All right, let's do that. So if random number is greater than 5, then we're going to do curly brackets. Okay, so let's look at the syntax here. First we had if in the purple. Okay, then we have random number. So this is our condition. Inside the parentheses is our condition. Inside the parentheses is our condition. Okay, under what circumstances do I do something? Then you have curly brackets, and then you have your code. So for example, we can console log number was greater than 5. All right, so our program will only do something now if the number is greater than 5. So let's give this a couple tries. Remember, random number is not, we have no idea what's going to be before we roll. So we're going to see how our program differs based on what the value of random number. So we'll run it. Okay, it rolled a 6 and number was greater than 5. We're going to roll again. I got a 5, and see how nothing was logged to the console? So our program did something different based on the value of random number, which is pretty cool. And that's also very realistic. A lot of times you won't know what's going to happen necessarily exactly at a given point in time, but you can plan for it. So we've got our if random number is greater than 5. All right, cool. Now we can do more. So we have other conditions we might want to do. So for example, else console.log number was 5 or less. Okay, let's think of this logically. We have a number between 1 and 10. So I get all the numbers that are greater than 5, not including 5. So one of the things you have to remember is if you do this, it doesn't include the number. So if random number is 6, 7, 8, 9, or 10, we will do this. Well, there's only so many other numbers, right? Because we're cutting into two parts, 6 through 10 and 1 through 5. So this else covers all the other options. Okay, so basically what the computer will do is it will check this first. Hey, is this true? If it's true, it will do this. If it's not true, it will go to the else statement. So basically else is like other. Okay, any other thing. Okay, if it doesn't fit the first if statement, go put it here. So let's give this a shot. Okay, number was greater than 5. I'm going to do roll again. Number was 5 or less. Isn't that cool how our program is doing things based on a variable that we don't know the value of before the program is run? All right, and so if you see number was greater than 5, number was less than 5. We have basically two different piles. Okay, we can split this up further. Okay, so if statements are not, you can have as many if statements as you'd like. Okay, we can divide things up how we'd like. So we'll go do that in the next video. So right now, just practice doing if else with just 2 conditions. But keep in mind, we can have as many conditions as we'd like. So play around with this for a little bit, and then I'll continue in the next video. All right, now there's more we can do with these conditionals. Okay, this part is called the conditional, because the condition that the computer is looking for to determine whether or not to run this code. So there's more we can do. I just gave a simple one we could use was greater than, but there are other ones you can use, and we're going to go over them. All right, so we have greater than. We also have less than. Right, so in this case, we're going to say if the random number was less than 5, so 1 through 4, then we'll say number was less than 5. And then this one will say number was greater than 5. Remember, the else basically means anything else. Okay, so if it isn't covered by the first condition, then it will drop down and come to this condition. So basically, if it's less than 5, it'll be 1 through 4, and then 5 through 10 will be the else statement. You don't have to actually put that there. You don't have to put a condition for the else. That's a common beginner mistake. You just have to do else because it's literally everything else. All right, let's save, and I'm going to go ahead and do node if then else. Okay, cool. So it gave me 8. Number was greater than 5. Makes sense. And again, number was less than 5. All right, so we've got our if else, and we were able to change this. Now let's do some other operations. So this is less than or greater than. You also can do less than or equal to. Okay, this will be inclusive. So if it's less than 5 or equal to 5. So all the numbers between 1 through 5. So we'll do less than or equal to. Save. Hit the up arrow so I don't have to type all that out again. Okay, number was greater than 5. We'll do it again. Number was less than or equal to 5. So 5 will be included in this one. All right, so you're able to use less than, greater than, or greater than, equal to, less than, equal to. We also can do this triple equals. This means is the number 5. So number was equal to 5. Okay, number was not 5. Okay, so if you think about it, again, I am trying to get you to think about logical groupings. Like, so basically, what are the logical outcomes? Here, there's two outcomes. Either the number is 5 or it's not 5. So if random number is triple equals to 5, then we do number was equal to 5. Otherwise, it's not equal to 5. We can try this out a few times. Yep, 1 is not 5, 10 is not 5, 9 is not 5. I'm just going to do a couple times to see if we can roll a 5. But it is random. There we go. Okay, and see, once I got 5, number was equal to 5. Okay, this triple equals checks to see if the left side is equal to the right side. We're going to go over the difference between double equals and triple equals, but I don't want to do that right now. We're going to just use triple equals. This is the easiest way for beginners to understand equality, right? So if random number is the same thing as 5, so basically are they both the number 5? The opposite of this is not equals. So if you put an exclamation point here, what you're saying is number was not equal to 5. Okay, what this means is this could be any number that's not 5. So 7, 10, 2, whatever. Those numbers would count, but as long as it's not equal to 5, then this will go. Okay, so these are the operators. You have the greater than and less than symbols. Remember the alligator? When I was a kid and we learned these symbols, the way I still remember doing this as an adult, I remember that the alligator eats the bigger number. So the direction that the thing is open towards is the thing that's bigger. So you can use greater than or less than or greater than or equal to, okay, if you want to include the number or not. This triple equals, we'll check to see if they're the same, and then exclamation point with 2 equal signs, we'll check to see if it's not that. Okay, play around with these for a while so you can get an a feel of how these work, because it's very important to do these in if statements. We need to be able to check different scenarios. I want to check to see if it is this thing or not this thing, or if it's bigger than this thing or less than this thing. So JavaScript, along with most other programming languages, gives us the flexibility to write our own conditionals, write our own condition statements, and then we're able to write our program the way it needs to be run. Okay, cool. So we've learned the basics, and we're going to expand on this in the next video to do multiple conditions. All right, let's keep our game going. Now, right now I have the game set up to where if you roll a 5, you win. If you don't roll a 5, you lose. Okay, so let's actually kind of change this up a little bit, because maybe we want to do more than just 5. Like maybe I want to do if you roll a 5 or a 6. Okay, so maybe there's like 2 numbers in the game that will allow you to win, and then everything else will be a loss. All right, the way we can do that is we can add additional logic inside this condition, all right, so that we can do something a little bit more complex than just greater than, less than, and equals to. So we can use the OR operator. So OR is double pipe, like this. Okay, it's above the enter key. You just hold down shift to do that. Okay, it's 2 of them. And then random number equals 6. So what this logic means is if the random number is 5 or, okay, that's what these symbols mean, or, random number is equal to 6. So if either one of those is true, we'll do line 10. Everything else will do line 13. You see how that else is really coming in handy? Else basically means, hey, if it's not covered from the above cases, just go ahead and do it. That way you don't have to think about the other cases. You only care about the case where they win, and then else will handle everything else. Okay, so this is how OR works. So let's give it a shot. So basically you win if you get a 5 or a 6. So I'm going to do node. Make sure I'm in the right folder. Okay, so we node if then else. Okay, cool. I got a 5 and I won. I got a 9, I lost. 4, 10, 2. What's going to do is 5 wins. Okay, so we're gonna do this a couple more times, like the dice roller is not being very happy with me. Come on, give me a 6. There we go. Okay, notice how both 5 and 6 win. Okay, so that means that either of those conditions can give me a win. That's what this OR operator is doing for us. Now, the cool thing is that you can have many of these. So, for example, maybe 5, 6, and 7 all win. Random number is equal to 7. Okay, so you can have as many OR statements as you feel like. I would advise against having too many because it might get confusing, but in this case, maybe the numbers 5, 6, and 7 all can be winners. So we can just give it a try, and make sure I save, and we just get it a shot, and then see if 7 wins, 6 wins, all right? So this way we can do OR, right? And that way we can do multiple conditions. Okay, these are more complex conditions. All right, that was OR. Okay, let's go ahead and do AND. Now for AND, what I'm going to do is I'm going to roll 2 random numbers. Okay, so I'm going to go ahead and do random number and then random number 2. And we're going to change the console logs just a bit so it's a little clearer what is going on. So random number 2. And remember, when we put strings together, we can use this plus sign. Okay, to put things together, random number 1 plus, right, and there we go. Okay, so now, let's say our game is, if so we're gonna roll 2 numbers, like rolling 2 dice, right? If the first dice is, let's say, 6, let's say they're both the same number, like let's say they're both 6s. Okay, so basically the first dice has to be a 6, and the second dice has to be a 6 to win. If you don't get 2 6s, you lose. Okay, I'm going to repeat that. The first die, which is this first random number variable, has to be a 6. And then this random number 2 also has to be a 6. If you get 2 6s, you win the game. If you don't get 2 6s, you lose the game. All right, so that is a condition that, like, we have 2 things that have to be met. 2 or more things that have to be met in order for the condition to be considered true. So, therefore, we're going to do if random number equals 6 and, so it's 2 ampersands, random number 2 equals 6. Okay, now this is not a high probability of winning. Okay, that's but what we're saying is this has to be true and this has to be true. Both conditions have to be true in order for it to do line 12. With OR, it could be either one of them. Like one could be false and one could be true, and that would be fine. In this case, they both have to be true. So we're not going to get too many hits, but we can try it a couple times. Okay, so I got 5 and 3, 3 and 10. Okay, so see how this one's 6? Okay, the first number was 6, but the second number was 9. Okay, and it still logged you lose. Okay, remember, this is not OR. This has to be true, and this has to be true. Okay, they both have to be true together. You can roll a couple more times to test it to see if you can get a double 6, but now you can see how AND works, and AND also can do multiple. You can do multiple ANDs together, as many as you feel like. Okay, but the main difference is AND means all conditions you give it have to be true, OR means any of the conditions you give it have to, like one of them must be true. Okay, so that is the difference between the 2 of them, right? AND and OR are very, very useful, so give this a little bit of practice and then continue on. Okay, let's talk about else if, right? When we have more than just 2 pathways for our program to run in. So far we've just been doing if and then else, which is great, like that's fine. But sometimes you have more possibilities, okay? Sometimes you have like 3 or 4 possibilities. And of course, JavaScript, as God's covered, we have this thing called else if. So let's talk about our game for a second. Let's say we have multiple conditions for you to win, right? So for example, if I'm rolling 2 dice, so we go back over our example, I have 2 dice, random number 1 is a number between 1 and 10, random number 2 is a number between 1 and 10. So I'm going to roll basically 2 10-sided dice. All right, so great. Let's say, for example, I get snake eyes, right? Snake eyes would be 1 and 1. So I could console log you got snake eyes. Now, remember this and, okay? So it means that this has to be true and this has to be true. So they both have to be true. And if they're both true, then you can say you got snake eyes. Okay, cool. All right. And then, well, I don't want my game to just basically say, hey, everything else you lose. Like, that's not very much fun. So I can have another condition. I'll do else if parentheses, and then put some brackets after the parentheses. And inside this if statement, I'll put a condition. Remember, the if statements have conditions inside them. The else does not need a condition statement. The else does not have a condition, just anything else. If it's not covered by your ifs or your else ifs, else will handle it. So else if, let's say random number equals 6 and random number 2 also equals 6. Okay, console.log, you win. All right, so in my program, the way it works is if you get 2 1s, it'll say you got snake eyes. If you got 2 6s, it will say you win. And if you did anything else, any other combination of dice, it will say you lose. But you see how this else if comes in handy, because now I can do multiple else ifs. Like maybe my program has 4 possibilities. Like let's say, for example, else if random number equals, okay, I don't know, lucky number 7. And the other one also equals lucky number 7. Okay, I'm just coming up with examples, but console.log lucky number 7. Oops. All right, so there you go. I've got 4 possibilities. In my program, if you get 2 1s, you get snake eyes. If you get 2 6s, you win. If you get 2 7s, it'll say lucky number 7, and everything else, it will say that you lose. And so I've got like 4, and you can chain as many else ifs as you want. And so now with these conditions, so we learned and and or in a previous lecture. We also learned about greater than, less than, equals to. So now you can pretty much cover just about any logical eventuality in your program, which is really nice. All right, let's run it a few times. Okay, node if then else. All right, cool. So I got an 8 and a 7. It said I lost. Oh well. Okay, I lost again. Okay, it's not very many ways to win in my program. Okay, cool. We got 2 6s. Okay, see it says 2 6s. So we go here. Okay, so look at the logic. It rolled a 6 and a 6 here. It went to the first if statement. Random number is as if random number equals 1. Well, the first number is not equal 1, so this was false. So in the AND statement, if anything is false, the whole thing is false. So the computer said, okay, cool, this is false. I will ignore this if block. Go to the next block. Random number equals 6, yes. Random number also equals 6, yes. Console log you win, and then it stops. Okay, so let's go to a previous one. Let's say 8 and 7. Okay, so it will random number equals 8. So this is false. So this first if statement is false. Then it goes to else if. This is also false. And it goes to this other else if. This is also false. So it went through all of the ifs and else ifs, and none of them were true. Then it does else. You lose. Okay, kind of go through that in your head. Remember, the computer is just doing it step by step, block by block, from top to bottom. Okay, it goes to the first if, checks this. Is it true or is it false? If it's false, it goes to the next one, then the next one. And then if everything above the else is false, then just do else. Okay, and else will pretty much cover anything that wasn't covered by the first few if statements. This takes a little bit of practice to get used to. We're not used, as human beings, used to thinking in such a categorical, methodical manner, but that's fine. Just kind of play the game a little bit, and then for each number in your head, work through why the computer gave you the output it did. Go through each condition. Is it true or is it false? If it is false, we go to the next condition. Then we go to if that's false, we go to the next condition. We're going to keep going through the conditions until we get to one that's either true or we get to the else block. Okay, we get to the else block, that means nothing above it was true. And play around with it. Maybe you can make the dice game do a couple different things based on different numbers. You can kind of play around with it. It's very important you take the code I give you and play around with it. It's very common for beginners to want to do exactly atom for atom what I'm doing on the screen because it makes you feel more secure. It's like a security blanket. Okay, but that's not really the spirit of programming. The spirit of programming is, okay, I've got a basic example and I'm going to like toy with it and stretch it and set it on fire and spin it, okay, till I can see how it works. Okay, so you have to be a little bit brave to want to experiment with your code. I can give you an example to start off with, but by all means, take this code and play around with it and see what happens. Sometimes in programming, we want the computer to do something over and over and over again, all right? So we did our guessing game, and it was pretty good, except the problem was that after the person made the first guess, the program stopped, like it didn't repeat itself. We probably would want the program to repeatedly run until the person gets the correct number. All right, well, let's see how we can go ahead and do that. So let's first learn for loops. For loops are great when you want the computer to do something a certain number of times. I'll put that down here. Great for when you want the computer to do something a set number of times. Like maybe you want the computer to do something 4 times or 10 times or 20 times or whatever. All right, so we're going to use a for loop, okay, in order to count some numbers. Okay, so first off, the command is for. All right, I mean for loop, for, that makes sense, right? Now, the inner part can be a bit frustrating, a little bit complicated for beginners, but once you practice it for a while, you'll get used to it. Okay, there's 3 parts to a for loop. First off is the variable, which we will use to keep track of our loop. So you might be thinking, what are you talking about? All right, think of a loop like this. Let's say we had 1, 2, 3, 4, right? Okay, this is like a list of things, and a loop would go through each number one by one. That's what I mean by loop. So we'll go to the 1, then we'll go to 2, then we'll go to 3, then we'll go to 4. Okay, I have to keep track of where I am in my loop. Like, am I in the 2nd spot? Am I in the 4th spot? Like, where am I? Okay, so when we do a for loop, we have to have a variable to hold our place in the loop. So I'm going to just call it I. You will see in multiple examples that most people use the variable I. It is not a special variable. It has no magic powers. It's just custom. It's like hello world. All right, so let I equals 0. So what I'm telling the computer is when my loop starts, I would like to start off at 0. So pretend we're doing our loop, and I'm saying, okay, cool, the first is going to be 0. We're going to start at 0. Okay, cool. The computer will then want to know, okay, when do we run the loop? Okay, it's going to run this loop so long as this part is true. So the second part is a conditional. Okay, like back when we did if statements, like, if random number was greater than 5. All right, I would like to run my loop, let's say 4 times. So I'm going to do I is less than 5. Cool. So what I'm saying is as long as the number of times I've gone through this loop is less than 5, keep going. So if I is 0, keep going. If I is 1, keep going. If I is 5, stop. Okay, because when I becomes 5, 5 is not less than 5, then it will stop. You'll see in a second what I mean. Okay, cool. At the end of the loop, I want you to take I and add 1 to it. We're going to do I plus plus. This plus plus, okay, means to increment. Take the number and add 1 to it. Okay, so if I were 5, I plus plus is 6. If I were 100, I plus plus is 101. Okay, take that number, go up by 1. This is our basic for loop. Okay, start at 0. Let I equal 0, start at 0. Do the loop until do the loop so long as I is less than 5, and then at the end of the loop, do I plus plus, add 1 to I. I'm going to console.log I. Okay, and save everything. And I'm going to show you the loop, and it'll become a little bit clearer. So I'm going to do node for loops. All right, let's take a look. We'll make this a little bit bigger. Okay, so again, I said I did everything over and over and over again. So I is 0, cool. Is 0 less than 5? Yes. So if this continues to be true, we'll do what's inside the for loop. So the first round, I was 0, cool. That it cleared this, so therefore we're going to run this code on line 8. You see how I console log 0, okay? And then at the end, it will do 0 plus 1 is 1, and then we'll go back to line 7. For loops, you can think of it sort of like this. It starts here, does what's in here. Once it gets to line 9, it comes back to line 7. It bounces back and forth between lines 9 and 7, back and forth until the loop stops. So you can kind of see it working, right? So we start off at 0, we console log 0. Cool, we're at the end of the loop. Go up by 1. Start back at line 7. 1, so 1 is less than 5, true. Okay, that's fine. So we console logged 1. 1 plus 1 is 2. Go back to line 7. Do it again. Is 2 less than 5? Yes. Is 3 less than 5? Yes. Is 4 less than 5? Yes. Now you're wondering, why isn't there a 5 here? Well, I was 4, right? So let's say I equals 4. We console logged 4. We got to the end. We added 1 to 4, which became 5. We went back to line 7. 5 is not less than 5. Okay, that is not true. 5 is not less than 5. Once this becomes false, the loop stops. Notice how the loop kept going. 0, 1, 2, 3, 4. But then once we got to here, it stopped. The thing that makes it difficult for beginners to get for loops is a lot is happening that you're not seeing. Okay? What you really need to be thinking about is it's bouncing back between lines 7 and 9. It'll start at 7, then do line 8, it'll get to line 9, and then it will bounce back to line 7. It's going to do this piece of code over and over and over again. That means that I'm not going to see anything afterwards till that loop is finished. So if I put this line here, the loop is finished. This code, lines 7 through 9, is going to be run 4 times, 5 times actually. So it's going to be run 5 times. Okay, and then it will get to line 11. So I'm going to go ahead and run this again. Okay, see how we got all the numbers and then we got line 11? Okay, this will happen over and over and over and over again until the loop stops. Once the loop stops, then we can continue on with our program. This is great because, like, sometimes I might want the computer to do something 5 times or 10 times or 100 times. So it can run the same lines of code over and over and over and over again for as many times as I want, and then once it's done, they can move on. Okay, this is what a for loop basically is. So again, to review, we have the for keyword. We start off with a variable. People generally use I. You don't have to use I. You can use like zebra. Okay, it doesn't matter. We just typically use I. Okay, I want I to start off at 0. I want my loop to run so long as this is true. At the end of the loop, I want you to take I and add 1 to it, and then start the loop up again. This it will go from bounce from line 7, 8, 9, 7, 8, 9, 7, 8, 9 until this part is false. Once this part is false, the loop stops, and then the program will continue on. All right, practice this for a little bit, run it a couple times and see if you can get it. We're going to play around with for loops for a little bit. All right, let's learn for loops. So this was the example we had last time, and for loops are look complicated, but once you get the hang of them, you'll be able to pretty much do them whichever way you want to do them. We're going to learn how to count down. So far we've been counting up. So if you look at our for loop, we have the first part, which is what number are you starting at? It could be any number you want. And this variable I, we just use I as a convention. It's not a magical variable. There's something special about it. You could call this violin if that's what you felt like doing. It does not matter. It's just a variable. We just tend to use I because it's one letter and it's less typing. That's really the main reason. All right, so we're going to start our loop at 0. I want to continue my loop so long as I is less than 5. So my loop will keep going as long as I is less than 5. Once I becomes 5 or greater, the loop will stop. Okay, at the end of every loop, I want to take I and increment it, go up by 1. Okay, for loops are all about doing the same code over and over and over again a certain amount of times. Okay, back in the old days, when we did BASIC and those other really old programming languages, you had to tell the computer to go to a certain line. You had to tell the computer go to line 138, and then you had to basically block off your code to where it would know which line to go to, and it was very, very, very confusing and annoying. So for loops, on the other hand, are a very nice compact way of doing the same thing over and over again. The for loop will start on line 1. Okay, it will figure out whether or not this condition is true or not. If it's true, it will do line 2. Line 2 will finish. It will get to line 3. It will do, at the end of every loop, it's supposed to do this. So you're saying at the end of the loop, I'm going to take I and add 1 to it. Great. It goes back up to line 1. It says, is this true or not? Okay, as long as this is true, it will do lines 1, 2, 3, 1, 2, 3, over and over and over again until this second part is no longer true. Okay, that is the whole point of a for loop. We can write something that does, the computer can do something 100 times, and we can write it with maybe 3 or 4 lines of code, and it's very, very convenient. All right, let's delve more into for loops by going the opposite direction. So far we've been counting up. Let's count down. All right, let's go from 10 to 1. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 kind of thing. So the first part is where I start off at. So I want to start off at 10. I would like my loop to continue so long as I is greater than 0. Okay, because think about it, 1 through 10, the numbers 1 through 10 are all greater than 0. Once it hits 0, I want the loop to stop. And then instead of raising I each time, I want to subtract 1 from it. So I minus minus will subtract from I every single time. So every time we go to the end of the loop, I will go down by 1. So I'm going to do node more for loops. Okay, and we can see that our for loop does what we expected it to do. It starts off at 10, I is 10, then I is 9, then 8, then 7. So remember, once we hit line 3, this I minus minus will happen. Okay, it will go down by 1. And notice how once it hits 1, it stops. Okay, why? Okay, we do the whole loop, we get to I is 1. Okay, then we do I minus minus, so I becomes 0. 0 is not greater than 0, so therefore the loop stops. Biggest thing for beginners to kind of have a problem with is this conditional part. Okay, this is the condition that says, okay, as long as this is true, the loop will continue. So now you can make loops that start off and stop pretty much wherever you want to. So I can make a loop that starts off at 20, okay, and starts right at 15. And you can even use a greater than or equal to we did back into back in the if statements. Okay, you do like greater than or equal to. You can kind of do the condition how you want. So I'm going to go ahead and save this and run it. All right, cool. So now it starts off at 20 and ends at 15. Okay, you could do whatever numbers you'd like to do. That's what the flexibility of the for loop. Remember, the point of the for loop is I would like to do a certain piece of code a certain amount of times. All right, well, we've learned how to go up with for loops. We've learned how to go down with for loops. So you should be able to practice for loops and get the syntax down. One piece of advice I have is try using Notepad to do your for loops. What I mean by that is in the olden days, back when dinosaurs roamed the earth, we didn't have these fancy IDEs like Visual Studio Code. We had to write all our code in Notepad. So I used to do, for example, I would have to do for loops without the use of IntelliSense. Okay, you would just type everything out like this. Okay, and it was, as you can see, not the world's greatest user experience, but I will say this, if you can write this for loop syntax out in Notepad without the use of IntelliSense, then you know the syntax. It's a piece, it's very hard, not, if you get it, then you get it, but if you're having problems with remembering the syntax, typing it out in Notepad several times so that you're not using IntelliSense can force your brain to think about what the syntax you're writing is so that you understand each individual piece. The first part is where do you start? The second part is under what conditions do you continue? The last part is at the end of the loop, what do I do? Okay, practice for loops for a little bit. They're very, very useful when you want to do things a set amount of times. But what if you want to do something until you want it to stop? Okay, for loops are not necessarily good for that. We have another loop called a while loop that we're going to learn next. Alright, so we learned for loops, now we're going to learn while loops. And while loops are very similar to for loops in that we are telling the computer to do something over and over and over again. The main difference between a for loop and a while loop is that the while loop, we don't really care about how many times we're looping through something. We really just want to loop through something until we tell it to stop. Right? So there is a difference between the two. But let's first learn the syntax of how to actually build our while loop. And if you haven't guessed already, it's going to begin with while and then parentheses. And inside the parentheses is going to be our condition. Essentially under what condition does the while loop continue? Let's make a variable outside of our while loop. Let's do let I equal 0. Right? It's just a random variable. You can call this potato if you felt like it. All right? It's no other meaning than I just picked I. All right? So I'm going to say while I is less than 5. Then squiggly brackets. All right? So this will mean hey, I want you to do what's inside the squiggly braces over and over and over again until this is no longer true. All right? The second that this condition is no longer true, then stop. All right, so I'm going to do console.log I, and then I'm going to do I++, meaning take I and increment it up by 1. So let's run this. We're going to do node whileloops.js, and as you can see, it starts off at 0. All right, so let's kind of imagine what the computer's doing. On line 1, I equals 0. We get to line 3, have the while loop. Okay, cool. So I is 0, so 0 is less than 5. Well, that's true. 0 is less than 5. So we're going to do what's inside the curly braces. So first we're going to console.log I, which is 0, and then we're going to add 1 to I. All right, cool. Then the computer gets to line 6. It says, okay, cool, we're still in the while loop, so we'll go all the way back up to 3. Okay, this time I is 1. All right, 1 is less than 5. That's true. 1 is less than 5. It will go and go do line 4 and line 5. I will become 2. The computer will get to line 6 and say, hey, I'm still in this while loop. I'm going to go back up to line 3 and do it all over again. All right, so this is a way of us being able to do something over and over and over and over and over again, all right, until we tell it to stop. So essentially, so long as this is true, okay, this will continue. Now watch what happens when we got to 4. All right, so I was 4, 4 is less than 5. Well, that's true. Console.log I, so that's why we got this console log right here. I was 4. Then on line 5, we add 1, so it becomes 5. We get to line 6, and we're still in the while loop, so we go back up to line 3. But now I is 5. Is 5 less than 5? No, that does not make any sense. 5 is not less than 5, so this becomes false, and then the while loop breaks. It stops doing anything. Okay? So that's the point of a while loop. This condition needs to be thought out. You need to know what condition you want the while loop to stop. So for example, this is with a number. A lot of times you might see a Boolean. So for example, let's make another while loop beneath this actually. Like for example, we say let game is in progress equal true. And you might say while game is in progress equals true. Okay, or if you don't like to do this triple equals true, you can just lop it off and do this with Booleans. All right, so this would be so long as this is true, it will continue the while loop. So this is a common way to use while loops to do like things over and over and over again until game is no longer in progress. All right, so you might have a bunch of code inside of here, and then eventually this becomes false, and then we'll break the loop. All right, be careful with while loops because if the condition never becomes false, it will run forever. Right? It will never stop because the condition will never be false. So make certain that you think to yourself, okay, cool, at what point do I want the while loop to end? So this is a good thing to practice. We will definitely use while loops in like games and things like that, but while loops are definitely useful. Remember, the difference between while loops and for loops is that for loops is when you want to do something a certain number of times. Like I want to do it 10 times, or I want it to loop through all the students in our roster, right? We have a set number of things and you want to loop through that number of things. While says I want to keep looping until I tell the computer to stop, which means you don't really necessarily know how many times you're going to loop through something. You just want to do it until something tells you to stop. So like for example, our game is in progress. Maybe when we end the game, we will set game is in progress to false and that will end the loop. All right, so that's the difference between while loops and for loops, and this is how we set one up in JavaScript. All right, so we have been using JavaScript and using console logs and looking at the terminal and seeing our output. But really, JavaScript was made to live in the browser. So I'm going to kind of show you how you can use JavaScript with a browser, like for example, Chrome or Firefox or whatever you happen to be using. All right, so I have a JS file, which we're going to put some code in a second. But we're going to make an HTML file. So I'm going to hit this new file. And I'm just going to say JS in the browser.html. Notice how the icon is here. Now, we do have a course on HTML, and I do recommend taking it, especially if you're doing JavaScript, because the two are going to go hand in hand a lot of the times. But you don't really need to know too much HTML for this current lesson, or for what the rest of we're doing in the rest of the current module. So what you can do is Visual Studio Code gives us a great boilerplate way to just make a quick HTML file without knowing too much about HTML. You can do exclamation point. Okay, you see how it brings it up? Like this is an actual thing that Visual Studio Code recognizes. And then we're going to hit it, and it will make boilerplate HTML code for us. You don't have to necessarily understand all of what this does, but it would be good if you got the basics. HTML is tags that hold information about different parts of the web page. We are going to take our JavaScript file and include it in this HTML document. And the way you do that is with the script tag. So I'm going to do this little caret, script src equals, and they'll put quotation marks in there for me. Then I will end it, and you see how script has an ending tag with a slash here. All right, now inside this quotation marks, we're going to point to our JavaScript file, so that way the computer knows where to get our JavaScript file from. Since they're in the same folder, okay, my HTML file and my JS file are in the same folder, all I have to do is dot, slash, And you'll notice that IntelliSense picks up what's in the same folder. So I can select my JS file like this and fill it in. All right, so now what will happen is when this HTML file runs, okay, when it opens, it will go and load this JavaScript file and run it for me, which is really convenient. So Visual Studio Code has these things called extensions. And as you can see, I have a bunch of different extensions. So people use Visual Studio Code for all sorts of programming languages and different tasks that they have to do. So some people like program with Angular, some people use Azure. Visual Studio Code allows you to install the extensions you would like to install so that you can be more productive. One extension I highly recommend is Live Preview. Okay, Live Preview allows us to preview HTML files while we're still in Visual Studio Code. It's not necessary. I'll show you what to do in case you don't want to add this extension, but the extensions are free. They take a few seconds to download and install. They're really nothing to write home about. So Live Preview, very useful as an extension. Live Preview, okay, I'm going to hit this again. If you hit this again, it will close the pane so you have more space. Notice in the upper right hand corner of the screen, I have this panel with this magnifying glass in the lower right hand corner. Notice how that's insignia does not show up when I'm on my JS file. If I'm in my HTML file, that insignia will show up because I have Live Preview. I'm going to click it, and this will show you what your HTML file looks like. Now mine doesn't have anything really in it, which makes sense. But what I wanted to do was I wanted to show off the console. So I'm going to click here. I'm going to open in browser so we can see what the web page looks like in a normal browser. Now you're thinking to yourself, Jonathan, this is boring. This is a blank white background. There's nothing. I don't see anything here. Let's go to DevTools. If you're using Chrome, you can hit F12. And in most browsers, Control-Shift-I also works. It depends on what browser you're using. You can look up DevTools for your specific browser. For Chrome, it's F12, and I believe it's also for Firefox. You can also use Control-Shift-I to open up the console. Now notice it has console highlighted here in the middle, and when we do that console.log, this is where we'll put it to. So let's go ahead and add one so we can see it's functioning. So I'm going to go back to, and close this, I'm going to go back to my JS file, and I'm going to console.log, you will see this in the console. Okay, I'm going to put a string inside, right? Now, I switch it up a little bit and use single quotes for strings. If you remember, strings can be double quotes or single quotes. I'm going to save my file. And I'm going to come back to, go back to where I would get in Firefox. And notice, you will see this in the console. What I put there was written to the console, so my JavaScript file ran. And this is a very typical way of running JavaScript, because JavaScript was really meant to be run in the browser. Okay, it is a scripting language. It is meant to give life to the browser, to add interactivity. So now we finally are able to connect a JavaScript file to our browser. So remember, just to go over it, you're going to create an HTML file. You can do so, let me just go ahead and do this, by the exclamation point in Visual Studio Code. Now in other editors, they may have other shortcuts, but for Visual Studio Code, you'll have the exclamation point. It will fill in some basic HTML. Then we do script, src equals. Since they're in the same folder, go back to the Solution Explorer. See how they're in the same folder? I can go ahead and use /JS in the browser.js, close it, okay, and save. And then I can just go ahead and write whatever I'd like in my JavaScript file. Here is another line of text. Okay, and then I can go back to my HTML file, and you can see anything I do in the console will show here. So now we can see the console here and get whatever we want. So if you did not get Live Preview, you can find your HTML file on your computer. You can find files by right-clicking and reveal in File Explorer. They'll open up, if you're using Windows, they'll open up a folder, and then you'll notice that you have an HTML file. And you can just double-click it and open it up in your default browser. So if you'd like to do it that way, you can do it that way. Live Preview is a little bit more convenient, okay, but there is definitely more than one way to skin a cat. Well, we've now added JavaScript to the browser, and now we can do some really fun stuff. All right, so we've managed to attach JavaScript to our browser, but let's do something a little more interesting than just doing console logs, because console logs are not something that the average person is really ever going to see. The person who comes to our website is not going to open up the developers pane and look at developers tools. So we need to do something a little bit more splashy. But there's some really fun stuff we can do in JavaScript. The entire point of JavaScript is to add interactivity to a website. So today we're going to learn prompt. All right, so what we're going to do is I'm going to ask a question of the user when they open up my website, and then I'm going to log what they typed in. It's very simple. I'm going to first make a variable to hold what they type in. So I'm going to ask them their name. So we're going to do let name equal prompt and then parentheses. All right, so prompt is a special method. Okay, we're going to learn methods way later in the course, but you'll notice it's yellow with this darker yellow for these parentheses. So you'll notice that this is like a special thing that JavaScript does. All right, and then what I'm going to do is inside, I'm going to put the thing I'd like to ask the user. So for example, what is your name? Question mark. All right, and then I'm going to console.log name. Remember, this variable name is going to hold whatever they type into my prompt. Now you must be thinking to yourself, what do you mean by prompt? I'll show you in a second. Let's make sure we save. Now there's a fun extension that I like to use in cases like these called Live Server. Okay, Live Server allows us to run our HTML by just right-clicking on the file. So go ahead and go into your extensions. You can go ahead and download and install Live Server for free. I'm going to go back to my HTML. I'm going to right-click on it and do Open with Live Server. Should pop up a browser. And here's our prompt. Okay, so what the prompt method does is, well, it shows this box, okay, with our question here, and a box for the person to start typing things in. So what is your name? We'll put Jonathan Hop. I'm also going to hit F12 to open up the console so we can see what we get back. So if we go back to our code, I said let name equals prompt. What is your name? This prompt is what brought up that box. Whatever they type is going to be held in this variable called name. And I'm going to log it to the console. So let's go ahead and do that. So I put my name in here. I'm going to hit OK. And notice that there it is. Okay, what I typed in, I just logged to the console. So this way, I can ask users a bunch of questions. It doesn't have to just be one question. So for example, what is your name? Let quest equals prompt. What is your quest? I'm going to go ahead and log that to the console as well. Console.log quest. I'm going to save. Right now, I've kept this open. Okay, this browser window open. So all I have to do is click back, and you'll notice that it refreshes. Okay, what is your name? Okay, Jonathan Hop. Hit OK. What is your quest? To teach people to change their lives. Okay, as you can see, you go through the prompts, and they'll go one after the other after the other. All right, so this is pretty cool. You're able to do a lot with this. Okay, because remember, we want interactive websites. We would like to do something with what the person, the information they give us. So you can make a lot of cool apps like this. So for example, we could ask people their name. We could maybe make a guessing game. We're going to do a little project with prompt in a bit, but I want you to practice with using prompt by asking, different questions and logging into the console. All right, and this is your basic pattern. One thing as a junior developer and anyone who takes my courses who is new to programming and trying to change jobs, I treat you just like a junior developer I would at a job. I'm going to give you lots of examples, and and a good idea to do is to follow them, because examples give us patterns. Okay, programming at its core is just about following patterns. Okay, I'd like to ask my user a question. Well, here's the pattern. Let variable equals prompt question. So if we look at this and break it down into a pattern, it's let variable name equals prompt question I want to ask. And basically, oops, let's put a P here. Okay, everything from this point is going to be a variation of this basic pattern. And so if you could think of it that way, it might be able to help you learn the syntax, because part of programming is also learning syntax and practicing it. So practice prompt for a little while, and then we'll continue on and actually do something with it. I'm sure you've used a website where it had a pop-up, something that came up to like let the user know something. All right, it's not so common nowadays, but back in the day when the internet was still fresh, we saw a lot of these things. They're called alerts. And once you see it, you'll know what I mean. All right, so I've got this alert in prompt.js, and I've got this HTML file. So this is the HTML file. It's going to, again, we have the script source equals alert and prompt.js. This is so when the browser runs, it will run the JavaScript. All right, so what am I going to put in here? I want to just like say hi to the user. All right, so I'm going to do alert, and then parentheses, and then, hey there, man, how's your day? Something laid back. All right, so alert, notice how it's yellow, parentheses, and inside I'm going to put a string, okay, some sort of message. So this is actually fairly straightforward. If I run the website, so I'm going to refresh, and here we go. Hey there, man, how's your day? So this is an alert, all right? We'll have a little box. It will have an OK button to dismiss the alert, but this is a way to like show a message to your user. So for example, this might be great for like if they do something and you want to let them know like, hey, here's the result of what you did. So for example, maybe like if you do like a prompt, okay, so we go back here, maybe we could prompt them and be like, prompt, hey there, man, how's your day going? And then they'll put something in, and you can just basically say that like that's great. So the difference between these two is prompt is expecting like a user input. Like you could put, for example, let answer equal prompt this. Alert is just an alert. It doesn't actually return anything. It just basically pops something on the screen. So let me save this. I'm going to refresh. Hey man, how's your day? Pretty good. Learning JavaScript. Hit OK. That's great. All right. And so it's basically just an alert, and knows that there's no user interaction here. It's just basically to pop up a message to the user, something short and quick. And again, you don't necessarily see these in websites nowadays, but at least you know how to do an alert in case you need to let the user know something. All right. What we're going to do is we're going to work on a small mini project throughout this course, and we're going to use the skills as we go along to create a guessing game. And it works just pretty much the way you think it does. All right, so I find projects to be the best way of learning programming. Like you learn new skills and then you can apply them. So for this guessing game, what we're going to do is we're going to actually apply a lot of different skills. So today we're going to talk first about pseudo coding. You're going to be thinking, what the heck is that? All right, so you may have seen me do this in previous videos, but if you do 2 slashes like this, it's a comment. All right, remember, comments mean that the computer is going to ignore this. So you can write little notes to yourself in the comments. All right, so we're going to do pseudo code today. All right, what pseudo code is basically I kind of think of like a blueprint or thinking out loud. Pseudo code is a technique that you use to try to organize your thoughts about how you would like to code a program. All right, so it kind of gives you a way to like organize your thoughts. A lot of times when you're programming, you can have a lot of thoughts running wild, and pseudocode kind of helps you narrow things down. All right, and let's do an example. So we have a guessing game. Okay, and again, our first draft of the guessing game is going to be okay, but by the end of the course, it's going to be pretty fun. So what is our guessing game? So the first thing we need to do in our guessing game is we need to have a hidden number. The number the user needs to guess. All right, well, we have our hidden number that the user needs to guess. Now, what happens next? See, pseudocode forces us to think like a computer. We have to do computational thinking. A computer is not a person. It's a hunk of metal and plastic. It doesn't have feelings. So we need to tell the computer in order, specifically, what we want it to do. And that means we need to think about that and try to discipline our mind. So I'm going to kind of model it for you. So we already did the first step. We need to have a hidden number, the number the user needs to guess. We then need to ask the user what they think the number is, right? Because that's the game. We could use prompt. So now we've thought about what we want to tell the computer to do, and we've also thought more concretely, what does JavaScript have in its toolbox that allows us to do this, right? So we thought about what we need to tell the computer to do in broad terms, And then we also thought to ourselves, okay, well, how does JavaScript accomplish that? Like, what does JavaScript have? What like functionality does it offer out the box that helps me to do these sorts of things? All right, so we've asked the user. Now we have to think to ourselves, okay, what do we want the computer to do? If the number they guessed matches, we say they won. That makes sense. But now we're thinking to ourselves, well, wait a second. This program is going to change based on the user's input because they may not necessarily guess the hidden number. In fact, that's the entire point of the game is that you don't know what the number is beforehand. Okay, well, that makes things interesting. So what do we do then? How do we handle that? Well, we're going to learn a technique called conditionals. So a conditional is when your program branches off into different possibilities. So let's think about it first in pseudocode, and then we're going to learn how JavaScript handles the situation. So I've already kind of started with if the number they guessed matches, we say they won. Another possibility is if the number they guessed is higher, we tell them they guessed too high. If the number they guessed is lower, we tell them they guessed too low. So this makes sense, right? Either they got the number, they match the number, they get higher than the number, they get lower than the number, and if they give us something that is not a number, we scold them. All right, so you see how pseudocode is helpful now? Like we haven't actually written our program yet, but now we have like a plan of attack. We have a very clear sort of, this is how we're going to build the program. And already from it, we've already kind of identified that this program is going to have to change. It's going to have to do different things based on the user's input, which is fine. That is the entire point of programming, is we want to be able to have fluid apps and fluid programs that do different things. But let's kind of go back again to the logic. We're going to ask them for a number. If the number matches, we say that they won. If the number they guess is higher, then we tell them. If it's lower, we do the same. And if they give us something that isn't a number, like if they say zebra, then we're going to kind of just basically say, sorry, that's not a number, okay, and end the game. Okay, so at the end of this, we end the game. All right, this seems like a really good plan of attack. There's a lot of little small things that we need to learn in order to kind of bring this to fruition. All right, how do we handle this logic of branching off into different possibilities? Okay, cool. How do we know that they gave us a number versus they gave us something else? These are questions that we're going to have to ask. Like we can handle the prompt, because I've taught you prompt so far, but these other things of conditional logic and telling whether or not the input that we got from the user makes sense, those are new techniques that we're going to learn. But this pseudocode helped us think through our problem, and now we can recognize where there might be holes in our logic, and we can go learn new things and try to apply it to the problem. Right? So this is an example of pseudocode. Let's learn some techniques we can use to sort of meet the requirements. All right, I'm going to go over the requirements for the guessing game, and I would like for you to try programming it yourself as a little mini project. Remember that it is very easy for you to sit here and watch videos and code along with me and feel like you understand everything I'm saying. And it's true, at the moment you're watching the video and we're coding together, at that moment in time, you probably do understand what I'm saying. The real test is when I'm not around, okay? That's when you really get to see whether or not you truly understood these concepts. So I hope you've been doing the exercises for each of the modules. And then when we do the project, like the guessing game, I would love it if you could just take a crack at it by yourself without me, and then come back and see how I did it in the project, okay, in the next video. Okay, but for this video, what I'm going to do is go over the requirements to make certain you understand what is being asked of you and what your program has to do. Okay, a lot of times when you write a program, you should ask for what's called requirements. Okay, your program should do something. All right, and so the requirements are a specific way of mapping out this is what the app is supposed to do at the end of the day. All right, you as a programmer write to requirements, so therefore you need to know what the requirements are. All right, so we have the pseudocode that we had made earlier. Let's go through it again. That way you're clear on the requirements. And then what I want you to do is try to program this by yourself, okay, without me. Okay, you have all the videos from the previous section. It has all the information you will need to complete this program. Okay, so the requirements. We need to have a hidden number, the number the user needs to guess. We then need to ask the user what they think the number is. So you could use prompt. So as you could probably guess, as I go through the requirements, your head should be thinking about, okay, cool, like what did we learn in previous videos that could accomplish this? So prompt. Also, you're probably going to need an HTML file, right? Then you're going to have to include your JavaScript file in it so that way you're able to prompt the user, okay, for their information. If the number they guessed matches, we say that they won. If the number they guessed is higher, we tell them they guessed too high. If the number they guessed is lower, we tell them they guessed too low. If they give us something that's not a number, we scold them. Okay, so basically, they give us something that's not like, they give us like zebra. Okay, remember the user could give us whatever nonsensical thing that comes to their head. Okay, the user is the enemy. We need to use our knowledge of casting and type of to make certain that they're giving us something that's a number. If it's not, then we need to figure out what to do in that case. All right, I'm going to say that the game is going to be finished after the first guess. Okay, so it does not have to loop. Okay, our first iteration of the guessing game is not going to loop. What that means is once they give you the number and you give them back something, then that will be it. Okay, so don't worry about having them guess multiple times just yet. We will add that functionality to this project as we refactor. Okay, but take a second, make sure you understand the requirements of what you don't have to do either. Okay, and then give it a shot, and then I'll show you how I went about it. All right, let's work on the guessing game. Now, there are a couple of small details I left out on purpose so that you would go and try it yourself, all right? Because again, programming is about doing the hard work of writing the code yourself, all right? That is when you're really learning. But let me show you how I would go about this. All right, so the first thing we gotta do is we need to have a hidden number, the random number that the user needs to guess. Now, the requirements didn't give a range, so I'm just going to say that the number is between 1 and 10. But the requirements didn't explicitly state that, so if you did a different range, that's fine. I left it open-ended to let you decide whatever you wanted to do. So I'm going to have a number between 1 and 10, all right? And then we're going to prompt them, so we need to ask the user what they think the number is. We could use prompt. So we're going to do let user number is equal to prompt. Please guess a number between 1 and 10. All right, that lets the user know what to do. Now we got a bunch of if statements, all right? And really the way that I know that these are if statements is because really the sentence begins with if. That is like a very huge clue that you're about to use if statements, all right? So let's break it down. So if the number is equal, we say that they won. If they guess higher, we tell them. If they guess lower, we tell them. And then if it's not a number, we tell them, hey, like, that's not a number. Aardvark is not a number between 1 and 10. All right, so let's do the first if statement. So I tend to my personal style is to first, if they do something wacky, kick them away. So for example, if they give us something that's not a number, well, we can't do a game like that. It doesn't make any sense, right? If they type in aardvark, we can't compare that to anything. So we'll do if type of user number does not equal number. All right, so this is going to check to see like, hey, did you give me a number? Like, I don't care what number they gave me as long as they give me a number. If they didn't give me a number, I'm going to alert them and say, hey, that's not a number. Okay, like, sorry, dude, that is not a number. All right, and then what else we'll do else if. All right, so now we know that the thing's a number. All right, but let's see if they win. If they win, that means the number that they picked is equal to the random number up here. All right, so we have random number up here. That is the random number between 1 and 10, so if they're equal, all right, so if user number is equal to random number, then we'll alert them to say winner, winner, chicken dinner. Okay, awesome. All right, else if, right now, in this case, if they guessed higher, that means the user number, the number they picked, is bigger than the random number. So if user number is greater than random number, all right, nice. We can do alert, sorry, you guessed too high. All right, and then the other option, the last option, is basically it was too low. So I'm doing if, else, if, else, if, else, meaning that pretty much gets all of the possibilities like there could possibly be. So we say, sorry, you guessed too low. All right, now we need to actually test this to see if this actually works. So I'm going to go and I have guessing game.html. All right, I've got that right here, so I'm going to run it. All right, here we go. Let's start. All right, now I don't know if my thing totally works now. We need to make certain that everything works by actually like playing the game. And I'm wondering if there's a bug or not, but let's just see. All right, so I'm going to type in 5 and say, hey, that's not a number. Well, wait a second, that is a number. Like, what are you talking about? Like 5 is a number. So let's go back to our code. All right, and our guessing game.js. Looks like there is a problem with this. All right, it looks like user number is actually going to be a string. So you may have noticed that prompt always gives you back a string. All right, so we need to be able, there's something wrong here we need to be able to like fix, all right, because maybe you did it this way, but this is going to be a string at all times because prompt always gives us back a string. So this line 10 is not going to work. Let's do something different. There's another method we can use that we did go over, and if you remember, it's how to check to see if things are or are not numbers. So we have that is not a number, okay, function that we can use. All right, so is NaN, and then we can put user number in. I can check to see like, hey, is this a number? So this will be a string when the person types it in, but then JavaScript will attempt to convert it to a number. If it can be converted to a number, then this will be true. All right, so you could do this, all right, but I don't want to do all that typing, so I'm just going to leave the equals 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 true part out. I'm just going to do is not a number. So if user number, if is not a number, user number, right? So it's going to check to see like, hey, is this something that can be converted to a number or not? So now let's give this a try. Okay, I'm going to reset my game. I'm going to put aardvark in here. All right, so let's see if that works. Hey, that's not a number. That's the expected result. I'm going to refresh my browser, and then this I'm going to put in a number, like let's say 4. Hit OK. Sorry, you guessed too high. Oh, that's better, right? Because 4 is a number, all right? That way we were able to go here. So when I typed in 4, this, okay, was false, right? Because 4 was a number. So then it went down to the next block, and the next block, and then the next block. So let's play this a couple times. So I'll hit OK here. And then if I want to play my game again, I want to refresh. Let's do, like, I don't know, 9. Okay, I guessed too high. So it looks like my guessing game is working. All right, I guess eventually it's always going to be random numbers, so I'll have to do this probably a couple times before it hits. All right, but at the very least, I know that I've met my requirements. I check to see that the user put in a number. Okay, so is not NaN is that method that we use, that function that checks to see, hey, can I take this string and turn it into a number? All right, well, if it's a number, then we're good. All right, then I check to see like, hey, is it equal to the random number? Is it or not? If it is, they win. If not, I tell them they guess too high or I tell them they guess too low. So in order to do this, we had to use math.floor, math.random that we learned before to create a random number. We had to use prompt. We even had to use this is NaN, which we learned, which may be difficult for some people. We also had to use alert to like alert the person that like, hey, like here's some information about the game. So as you can see, a real program takes all of the different aspects of JavaScript we've been learning and combines them together in order to do something. All right, let's keep chugging along. There's way more JavaScript to learn. So far with variables, we've been able to hold one thing, like a single number or a single person's name. Like, so for example, we did let full name equals Sam Winchester. All right, but this is one person, right? Like, so there's a single Sam Winchester, but there are other characters we might want to have. We might want to do something with them. So just a string is not going to cut it if there's more than one string that we want to deal with. So if we want to deal with a collection of data, then we can use what's called an array. So let cast equal, and an array is denoted by these brackets. All right, so you'll see we have square brackets here, and inside we can put values. So let's say, for example, we've got Sam Winchester, we've got Dean Winchester, we've got Amara, and we've got Castiel. All right, so notice how I put the string, then a comma, another string and a comma, etc., etc. Now I have multiple characters, all right? So I have multiple strings that are bundled together into this what's called an array. The cool thing about arrays in JavaScript is that they can be mixed. So for example, I can have an array. It doesn't have to be all strings or all numbers. I could do this. Okay, where I have a mix of numbers, booleans, and strings, right? So this is cool. You get to mix up what you want, and you can just basically say, okay, cool, I'm going to put a thing here, comma, another thing, comma, another thing, comma. And you can put as many things as you want in an array. Each thing in the array is called an element. All right, so this is an element of the array, Sam Winchester. Another element of the array is Dean Winchester. All right, so arrays have elements, and they're at certain positions. So JavaScript is a zero index language. That means when we start counting things in an array, we start with 0. So we say what position Sam Winchester in the array, we say it's at position 0 because it's the first element. So Sam Winchester is 0, Dean Winchester is 1, Amara is 2, and Castiel is 3. It's very easy to mix this up because human beings are, one index. We start counting off at 1. All right, but you have to remember with arrays, you start counting off at 0. So you might be thinking, well, Jonathan, why are you bothering with that? Like, why do I care if it's 0 index? Because when we have an array, let's say we wanted to get a single element from the array. Well, we can get it at a certain position. So what I'm going to do is I'm going to console.log cast, and I'm going to put square brackets, and I'm going to put a number inside these square brackets. All right, so what do you think is going to actually show to the console when I run this program? Right, console.log cast square bracket 0. What I'm saying is I want the element at position 0. All right, so let's give this a shot and see what happens. All right, so node arrays.js, Sam Winchester. All right, so by doing cast bracket 0, I'm getting the value at position 0, which is Sam Winchester, which is why understanding the positions is important. Remember, it's a 0 index, so it means it's the first element is 0, and then you start counting up from there. So here, if I did 2, what do you think will appear on the console? Amara. All right, that way you can grab the elements from the array based on their index. Okay, so this index is this number, the position of the element within the array. So arrays are great. I mean, they're really simple to use. It's awesome when you have more than one thing. All right, so having a single string, a single name is cool, but having multiple things, I want to bunch them together, I can use an array. An array is denoted by this square bracket, and then each element inside is separated by a comma, except for the last one. You can mix types. You can have an array with numbers and strings and booleans, all you'd like. Typically people keep it to one thing, but like I said, there's no rules. So you can have 10, True, and Bob all in the same array if that's what you felt like doing, because this is JavaScript and it does not tell us how to live our lives. All right, that is the first part about arrays. Remember, the whole point of this is remember their index, and that arrays are collections, putting multiple pieces of data together. What if we wanted to know how many elements are in an array, right? So arrays have a bunch of different built-in functionality that we can use to kind of answer this question, right? So I've got this array for fruits. I did let fruits equal, then I've got my square brackets to indicate it's an array, then I've got strings, orange, banana, grapefruit, strawberries, right? So how many elements do I have in this array? Well, obviously you could just count, but like what if we are getting a huge array with a bunch of stuff in it? All right, there's a property of fruits, because fruits is an array, so I'm going to do console.log fruits.length. Okay, so there's dot length. Length is a property of an array. So when I did this dot, it came up. See, I started typing LE and then it just came. So length is a property. So let's see what happens when I do this. I'm going to do node array length.js. This is 4. What does that mean? It means that there's 4 elements in this array. So if I add another element, let's say I add dragon fruit, right, and I run my program again, I have 5 this time. So now this length property will tell me how many elements are there in my array, which is pretty handy, especially if this array gets to be really huge. All right, so again, dot length, so I said let fruits equals this array, and because fruits is an array, then we can do fruits.length. Okay, length comes with arrays. It comes right out of the box. You do not have to create the length. It just comes with JavaScript. You don't have to do anything. Right, and length will answer the question of how many things are in my array, how many elements. It'll give you a number, whether there's 4, 5, 0, whatever it happens to be. All right, let's learn about some methods we can use with arrays. Just like we had strings, like strings had to uppercase and to lowercase, those are functions that were associated with strings. Arrays have a lot of great functions we can use that help us to do our work. All right, so I've got an array of planets. All right, they're all strings. They've got the different planets of the solar system. Sorry, Pluto, you're not included. Right, let's say I want to put this in alphabetical order. Obviously, you could type that yourself, but let's say I want the computer to do it because the computer can do it faster and I'm a lazy programmer. All right, what I'm going to do is planets dot sort and then put parentheses to indicate that this is a function. This is a piece of functionality that I would like the JavaScript to go do. All right, and notice when we did planets dot, there were a bunch of different methods or functions that are associated with arrays. Find index, fill, filter, join. There's a bunch of them. And we're not going to go over all of them. We're going to go over a few of them that I think are very useful in your job. All right, and ones I think that are good for a beginner. Maybe more advanced, we'll do things like filter, but for right now, we can do simple ones like sort. All right, so we have sort, and it does exactly what you think it does. So I'm going to console.log planets. All right, and then I'm going to save, and then I'm going to run this with node array methods.js. All right, and so if you'll notice, then it prints everything out in alphabetical order, starting with E. E, J, M, 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 A, M, E, N, S, U, V. Right, so you got all the different planets of the solar system. So sort was able to do that with strings, so basically be able to take the strings and put them into descending order, starting with Earth, okay, which occurs at the top, and then everything goes down. So again, this is pretty cool, especially if it's like a really big array with lots of stuff in it, then you could easily sort through them. Now, if you try this with numbers, you might be surprised. So let numbers equal, I'm gonna make an array of just some random numbers, 65, 1009, 2, 56, 127, okay, just some random numbers I put together. All right, we're gonna do numbers.sort. And you might be surprised at the result. Okay, I'm going to console log it, and I'm going to go ahead and comment out the one with plants. That way you really only see one thing in the console. All right, so I'm going to run it. And you'll be like, well, wait a second. When we did sort with strings, it was able to just basically go Earth, Jupiter, Mars, Mercury, etc. Right? So it just went from descending order. When we did numbers, well, it put 100 here, then 1009, then 127. Like, there clearly is not an order here. All right, so with numbers in JavaScript, the sort method doesn't really work the way you would expect it to work intuitively. We've got to actually add a little something something into the sort method to basically tell JavaScript, here's how we want you to sort these things. So it'll work out the box with strings. If you want this to work with numbers, you're going to have to do something like this. We're going to add a special little function inside of here. We're going to learn more about these later, but this is just in case as a beginner you use sort and you're like, why is it not working with numbers? We're going to do parentheses, A, colon, B, colon, comma, B, arrow, A minus B. And you'll be thinking to yourself, what on earth is this voodoo? All right, this is basically a lambda function, and you're going to learn more about this in the more advanced section as a beginner. I don't expect you to really get this. But if you want to use sort for numbers, now we're going to try it out with this in here. And you'll notice that actually now the numbers will be in order. All right. This is one of the quirky things about JavaScript. Sometimes the functions that it has built in don't work the way that we think that they work. And so sometimes we have to go into these little details to make certain that we're not confused. So when we do sort on strings, it works the way we think it does. And when we do sort on numbers, we have to add this extra what's called a comparator. I'm going to put a little note here, comparator. That basically is like a function that allows JavaScript to know how should it compare the numbers. All right, so this is just good to have in your back pocket. That way when you're doing sorting and you have an array, you want to put things in order, you know how to do it. What if you wanted to add or remove things from your array? All right, so we've got an array here of strings, James, Bob, and Joe. So let's pretend, I don't know, that they're customers or something, right? You can think of whatever context you want that might fit this. All right, let's say we wanted to add a name to this array. All right, so how do we do that? Well, we have a bunch of methods that we've been learning about. We learned about sort last time. Now let's learn about push. We do names.push, And then I'm going to go ahead and put a string in here. Let's say like the new customer is Shannon. All right, awesome. Then I'm going to console.log names, and we're going to see what this push does. All right, so I did names.push Shannon, and I'm going to run it. The JS, and you'll notice that Shannon has been put at the end of the array. So we had James, Bob, and Joe, and then Shannon had been added onto it. All right, so if we do push again, let's do names.push Shaniqua. All right, we'll see what happens. All right, so notice it does it in order. All right, so what push does is it puts the new thing at the end of the array. You can think of it that way. All right, so we start off with James, Bob, and Joe. Then we did push Shannon, which adds Shannon to the end, and Shaniqua, put Shaniqua at the end. So you can be able to add things onto your array, which is pretty cool. Now the opposite, let's say we want to get rid of things in our array. All right, so there's a couple ways to do that. One way we're going to learn today is names.pop. All right, I'm going to go ahead and run it. Okay, so I'm going to go ahead and add Shannon and Shaniqua, and then we're going to do pop, and we're going to see like what it does. All right, so let's run it again. All right, so on line 6, we had all the names we had before. Then on line 8, I told pop, and then we decided to console log names again. So what did it do? So basically what pop does, it takes the thing at the end and gets rid of it. All right, so you're able to get rid of the last thing that was put in there. So you can push things into the array, which will add them to the end of the array, or you can pop things from the array, which will get rid of them. All right, so that way push and pop are sort of like opposites of each other. You can either push things, some people think of it as like appending to the array. I like that. So you're like putting it at the end, and then pop is basically saying, okay, cool. Like you can think of it like, I don't know, twisting off a bottle cap. Like you pop the thing off, right? So it's gone. All right, that way you can add things and remove things from the end of the array. So push and pop are very, very common methods for arrays. All right, now we've been able to use pop and push to add things at the end of the array, but what about the beginning? Right, so we have methods for those too. All right, so let's learn the first one. We're going to do names.unshift, and then I'm going to put Harry. All right, and I'm going to console.log names, and we're going to see what this unshift function does. So node array methods 2.js, and bam. It looks like it added Harry to the beginning of the array. So before it was James, Bob, Joe, Martin, and Xavier, and then now we have Harry at the beginning. The cool thing about Unshift is you can do multiple things. So we do Harry, Curly, Mo. So I've got 3 things in here. So I'm going to go ahead and run it. And notice how it puts those 3 things in the front, and then it continues on with the rest of the array. So now with Unshift, you're able to add elements to the front of the array. So it is all about like basically where do you want the data to go. If you want the data to go at the end, you're going to use push, okay? And if you want the data to go at the beginning, you're going to use unshift. Now, removing things, all right, well, is shift, right? So you can basically just use shift. We don't put anything inside of here, right? And what that will do is it'll get rid of the first element, all right? So in this case, that would be James. So if I run this, I'm going to use shift now. Notice how it's Bob, Joe, Martin, and Xavier, right? So it took James and lopped it off, right, from the beginning. So with arrays, with these methods, we've got pop and push, and we've got shift and unshift. So the difference between them is basically, do you want to add things or remove things from the end of the array, or do you want to add or remove things from the beginning of the array? Right, so the beginning meaning this part, or the end meaning this part. So that allows you to kind of pick and choose where do you want to put things. Do you want to put them in the beginning, or do you want to put them at the end? And also with unshift, you can put multiple things into your array. All right, so now we can really manipulate our array and add information to it or remove things from it at will. So far, we've been using functions for strings like to uppercase or to lowercase. We even learned about is not a number. What if we wanted to make our own functions? Like we needed our own custom functionality. Well, in JavaScript, that's pretty easy. We're going to learn the function keyword. So all you got to do is type function, and then give your function a name. And again, the name of the function can be what you want it to be. Typically, we like to do camel case. So for example, let's say I had a function to take 2 letters and add them together. So I'll call it sum. All right, and then I'm going to do a parentheses and curly brackets, and this is the minimum you need for a function. So you use the function keyword, the word sum, which is again is a name. This could be potato for all we care, parentheses and curly brackets. And the function basically is saying, okay, cool, when someone calls the sum function, we're going to do everything inside the curly braces, right? So let's add some arguments. So we want to sum two numbers together, all right? So we're going to do sum A, comma, B. So the first, we're expecting, when someone uses this function, what we're saying is we expect two arguments. When they call the function, they got to give us two things. And we're going to call the first thing A and the second thing B. Again, this is a potato. We can call this aardvark, and we can call this maybe like zither, right? These are just variables. There's nothing special about them. Common beginner mistake is to think that the computer is like understanding what these variables mean in context. It does not. We just give them names and that's it. All right, so we've got this these two numbers A and B, and we're going to add them together and we're going to return it. All right, so when your function returns something, it means basically the function is going to run and it's going to give back a value. So I'm going to return A plus B. All right, so the return keyword, you see, has a different color, and I want to take A and add it to B. All right, now this function does nothing by itself. So if I were to go to my terminal and then just run node functions.js, nothing's going to appear on the console because the function does not just automatically run. We have to actually tell the computer, hey, I wrote this function, now I would like to run it. So what I would like to do is I'm going to do let sum equal, well, let's actually call something different. Let's sum of two numbers equals, and then we're going to call the function now. You put the name of the function, parentheses. Now this function is expecting two things, two arguments. So when we call the function, like we're doing on line 5, we got to give it two arguments. So I'm going to give it 1 and 2. So what I'm telling is cool, run the function sum with the arguments 1 and 2. When it gets to here, A will become 1 and B will become 2. It will then return 1 plus 2, and what it returns will be saved in this variable sum of two numbers. Then I'm going to console.log sum of two numbers, and we're going to see what we get on the magic console. We get 3. All right, so line 5 says, okay, cool, run this function. It has two arguments, so here you go. The first argument will be 1. The second argument will be 2. Then the computer will come up to line 1 where the function sum is. The variable A will become 1. The variable B will become 2. And then it will return, okay, A plus B. We'll take that and save it into this variable called sum of two numbers, and then we'll console log it. The cool thing about functions is that because they're just like generalized functionality, I can put like different numbers in here, and then it will work. Right? It'll be able to sum them for me. So it takes any two numbers it gives me, I give it, and then it will return it. All right, so it will give us back a value. It is very easy for people to mistake return for console log. One of the common beginner mistakes with functions is people think that like return prints something to the screen. It does not. Return basically means run this function and then take whatever value I'm returning, giving back, and save it to this variable. So for example, if I got rid of this console log and just did let sum of two numbers equals sum 1022, nothing's going to show to the console. See, it's blank. All right, so return does not mean print to the console. One of the things that beginners get caught up with is they think the console is the thing that the end user is going to really see. Most of the times, in like maybe you're taking a boot camp right now, or maybe you're studying JavaScript on your own, the console is really more for developers than anything else. The average person is rarely ever going to see the console. They're most likely going to see like a web page or things like that. So return does not mean that someone's going to see anything. Return basically means when this function finishes, take the return this value, meaning whoever called the function can catch the value this returns. So for example, I could even just remove this, in which case the value that's returned wouldn't go anywhere, right? It would just be sum 1022, it would return 10 plus 22, but it wouldn't get saved anywhere, so it wouldn't do us any good. So that's why we usually make a variable to hold what's being returned. Now functions don't have to return things. I could create a function that doesn't return anything. So I can say like function say hello, and I could just put console.log hi there. All right, notice this function doesn't have any arguments. This is blank, right? So nothing goes in there. And then I'm just console logging hi there. I'm not even returning anything. So this function doesn't return anything, and that's perfectly fine. So I can call this function by doing say hello and then putting parentheses, and this parentheses means, hey, do the function. Go to line 5, start there, and then start doing the code from there. All right, so if I were to run this, okay, hi there, it will put whatever is inside the function. You can have multiple lines inside of a function. You can have a function as small or as large as you'd like. There's even more stuff in here. Okay, I'm going to go ahead and run this. All right, so it will just basically function. What really function means is, hey, go to this line starting, here, and then start doing the code line by line by line by line. That way we can run it over and over again. So I could do say hello multiple times, or I could do sum of two numbers multiple times. So let's actually do that to demonstrate. So the cool thing about functions is that they're reusable. I can do console.log sum of 10 and 2. I could also do console.log sum of 105,000 maybe. So you see how I can call this function over and over, and it saves me a lot of typing. I don't have to rewrite this over and over and over again. I can write it once and then call the function multiple times. This goes to the principle of do not repeat yourself. You may have heard of it before. It's called the drive principle. Don't repeat yourself. That way functions help us do that. I don't have to repeat myself. I can just use this sum function over and over and over again with different numbers, all right, and it will be able to get me, okay, the sum of those numbers very easily. That way I don't have to constantly rewrite code. All right, so again, to recap, you use the function keyword, then you give your function a name, and again, you choose the name. It could be Farfek-Newton or whatever you want it to be. Then functions can have arguments, right, some parameters, basically like, what does a function need to bring in? What data from the outside world is coming into the function? You don't have to have it. So sum has 2 arguments, whereas say hello has none. And that's fine. You choose. Your function can return a value basically saying like here's a value back. It doesn't have to have a return. So there are functions that have returns, like the sum function. There are functions that have no returns, like say hello. Return does not mean print to the console. Okay, big beginner mistake. Return does not mean print to the console. All right, that is those are 2 completely different things. Functions exist to basically cut down on code repetition. Instead of writing the same code 10 times, you could write a function to do a block of code, and you can reuse it over and over again. Right, that's the basics of functions. All right, now that we're familiar with functions, I can show you a concept called scope, which is very, very important in JavaScript. Well, it's important in any programming language, really. So variables, all right, we've got this function called say hello, which takes in a full name and says hello there plus full name. So this is basically a function that will just take in someone's name and then give them a nice greeting. All right, so I'm going to go ahead and run it. I'm going to comment this out first. We'll do say hello, and then we'll do Jonathan as the argument, and then I'm going to go ahead and run it. So do node scope.js, and see it says hello there, Jonathan. All right, so we know how functions work. Jonathan got passed into the function. That means that when say hello is run, it takes this value Jonathan, and this variable full name will become Jonathan, and then the function will carry on from there. So this variable full name, where does it exist, right? So scope is basically about variables and where they exist. Like, where do they have values? Does the computer know what full name is, and then under what context? So full name will have meaning within the scope of this function. The easiest way to think of the scope of the function is basically the beginning and ending curly braces. So this is like the zone of the function. It begins at this curly brace here and ends at the curly brace of line 3. Any lines between these two is going to be inside the scope of the function. So now, what do you think will happen if I try to console log full name? Here, full name is outside the function. So notice the function begins here at this curly brace and ends at this curly brace. So line 5 is outside of the scope of the function. Let's see what happens if we try to console log full name. We get an error, all right? Full name is not defined, okay? We get this is because we're trying to deal with a variable that's out of scope, all right? Full name exists within the scope of the function. So if I were to move line 5 and move it inside the function, so see how I'm still between these two curly braces, and let's say I try to rerun my function, my file, okay? So notice how it didn't error at all. Oh, let me actually use the function. So say hello, Joe, right? So if I were to run this function, notice how there's no error. Why? Because full name exists within this function because it's one of the arguments of the function. Okay, that's why we use this term pass in. Okay, Joe is being passed into the function, meaning that this value Joe is coming into the function as the variable full name. So within the scope of this function, full name has meaning. The computer knows what you're talking about because it's like, oh, okay, when you call the function say hello and you put Joe inside, then full name is Joe, and I know what to do with that. Once we leave the scope of the function, though, if we were to use full name, the computer has absolutely no idea what we're talking about anymore, all right? Because it's sort of like, well, we didn't declare full name anywhere, so what is this? That's why if we were to try to run this, it's going to give you an error. So JavaScript, remember, JavaScript runs until it finishes or it hits a wall. So if we have an error, like a reference error like this, it's just going to stop. Like it just does not know what to do. It doesn't know what full name is outside of the scope of this function. All right, so that also means that then any variable you declare inside the function is also not going to be outside of the scope. So even if I went like let age equals 10, right? Age is inside the scope of this function. If I try to do age, like let's say I do anything with age outside of it, like console.log age. All right, and if let's say I try to run this, I'm gonna get an error. All right, it's going to be age is not defined because it has no idea what age is because I'm using age, but age was declared inside of the scope of the function. All right, so where the variables are and where they're declared is very, very important. All right, because you might get errors and wonder like, why is this giving me this not defined error? Probably because you're trying to use a variable outside of its scope. With functions, the scope begins at the first curly brace and ends at the last curly brace. Anything inside of it is within the function scope. So inside the function scope, any arguments that come in, like this full name, the function will know about it and it will be able to work with it. You also can declare variables inside the function and then the function will know what to do with them. Outside of the function, they will not have any meaning. The computer will not know what to do, and it will give you a reference error, just like you're seeing here. Let's say we have an application that organizes students at a university. All right, so let's say we're working on that. We've got 3 students so far, James, Bob, and Billy. James is 19, Bob is 21, Billy is 22. James is from Detroit, Bob is from Chicago, Billy is from Los Angeles. All right, so we've got all these multiple students and multiple ages and multiple places where they come from, and so we have 3 arrays to hold the different kinds of information related to each student. So this is one way we could do it, but this is kind of unwieldy. Look how what I have to do in order to be able to tell, like, James is 19 years old from Detroit. So I'm going to run this. Okay, so I essentially had to keep track that the index was the same. So the names array holds the name, age holds the age, and hometown holds the hometown, and that 0 is the first student, and Bob is the second student. This is kind of an unwieldy way of grouping data together, because really what I would like is to have one thing that says James, 19 in Detroit, and put those together, and have Bob, 21 in Chicago, put those together, right? Because they're one person. I would like to have one person have a group of things, a group of values. I can group them together, and that way it makes sense because James and 19 Detroit go together. Bob, 21 Chicago go together. That way I don't have to like do what I did on line 5. So I mean it's doable, but like the bigger these arrays get, like picture a real life university. A real life university does not have 3 students; it has thousands of them. So this will be very, very unwieldy very quickly to have to put all this data in 3 different arrays and then combine it again later in order to form a person. So JavaScript gives us a much better way of doing this. All right, so I'm going to just basically get rid of all this stuff. I'm going to comment it out. Okay, and we're going to do some new code. We're going to do objects. All right, so we're going to do let student1 equals, and we're going to do curly braces to indicate that we're dealing with an object. An object is a grouping of data, right? You're taking data and you're grouping it together for convenience. Okay, it's data that goes together for some reason. Object-oriented programming is all about thinking about programming tasks, okay, so our requirements in terms of objects or groups of data. Object-oriented programming is great because as human beings, it's easy for us to relate to the world in terms of objects. There's electronics, there's animals, there's people, there is countries, like there are all of these things that we can represent as objects because we think of it that way. It's like more comfortable for humans to deal with. So here we're going to take a student number 1 and we're going to say that his name, okay, so we do name is James. Okay, what I did was I put the property of the object, this is the property, name, colon, and then whatever it was, in this case it's a string called James. Then I can do comma and do the next one, age, 19, hometown, Detroit. So now student 1 is this nice little package of data. It's all the data related to this first student. So now if I want to print out stuff about him, I could access it from the student 1 object. Well, how do I do that? We're going to use what's called dot notation. All right, so for example, let's say I wanted to get James's age. I'm going to use console.log, just so we can put it to the console. I'm going to do student1, which is the name of the variable, dot, and then you can see that these things popped up, like name, hometown, and age. All right, let's do age, for example. All right, so I did student1, which is the object, the variable, and then dot, and then the property, age. I could just as easily done name or hometown. All right, so now I'm going to do node object.js and see it prints out 19 because the student 1, the age is 19. This is really great because I can have multiple objects. So I have let student 2 equals, curly braces, name is Bob. Okay, Bob is 21 and his hometown is Chicago. Right, I'm going to console.log student2.age. Right, so notice how this is student 1, and I name this one student 2. Again, I can name these variables what I want, but notice that they represent different groupings of data, but they both have a name, an age, and a hometown. So that way, when I run this, notice I got 19 for student 1's age, but 21 for student 2's age. So now I'm kind of able to differentiate between them. All right, so this is the basics of objects. You can create an object by creating a variable, and then these curly braces indicate that you're making an object. The object is a grouping of data. All right, you can have as many properties as you'd like. So the property goes on the left, then a colon, and then on the right is the value, meaning this student 1's name is James. His age is 19 and his hometown is Detroit. All right, and you guys many of these as you want. Always remember your commas afterwards. And now this is way more convenient. Like let's rewrite this whole thing, except this time using objects. So I could do console.log, okay, and then we're going to use dot notation. Use backticks for the interpolation. So we can do student1 dot name. Okay, remember that dot and the property will give us the value. Use more interpolation. Student1 dot age, years old, and is from student1 dot hometown. Okay, and looking at this makes a lot more sense if you look at it. Like here, it's like name 0, age 0, hometown 0. Well, what is that? Here, it's student1 dot name. Oh, it's the student's name. It's the student's age. It's the student's hometown. Okay, that makes a lot more sense visually. We get to see like how that, like as a programmer, this line 19 makes much more sense to me. All right, so we were able to create an object. We were able to set the values of its properties. Each object has properties. We were able to set the values, and they were able to use dot notation to get back those values. One little thing is if you try to use dot notation for a property that doesn't exist, So for example, let's say I did console.log student1 dot is for like a year in college. All right, notice how there is no year in college property on either of these students. It doesn't exist. So let's see what happens if we try to run our program. We'll get undefined. All right, what that basically means is that, that no value is set. All right, so there is no value associated with year in college. It's not set. Okay, it's undefined. We don't know what it is. So keep in mind, you want to make certain that you're being consistent, so that way you're using properties that are actually set for the object. Okay, otherwise you're going to get undefined, so that may be confusing. But you can just, go ahead and add properties after the object is made as well. So for example, I could do student1.years in college equals 1. And then I'm going to console log it this time. Student1.years in college. Okay, and let's run this. And now it says 1. So even though years in college was not a property of the student when I first made it, I can still add that property later and assign a value to it. So that's kind of the flexibility of JavaScript, that I can just basically say, okay, cool, I have this object, here are its properties, maybe later you want to add a property, and then set a value, you can go ahead and do that. That's perfectly fine. So you just use dot notation, student1.years in college equals 1, and then voila, it's there. If you don't do this, if you don't set it and try to use it, you're going to get undefined. Okay, basically meaning like, hey, it's not actually defined anywhere, it's not set, like this doesn't mean anything until you actually give it a value, right? This is a great way of bundling data together. The whole point of an object is to take data and bundle it together into a nice, neat little package like this, which is way better than trying to use like multiple arrays to group things together. All right, let's talk about classes. So before we had objects where we would do things like let student1 equals, and then we had the curly braces, and we did like name, James, age, 20, hometown, Boston. All right, so this was cool. We had objects, and we could do student1 dot name, and that was a very convenient way of bundling all of this different information to one package, which is this object. The problem becomes is like we have let's say we have like a bunch of students, so we have like maybe like let student 2 equals, and this gets to be very repetitive because now I have to like essentially do the same thing over again for this new student. Let's say his name is Steve, he's 22, and his hometown is, I don't know, Houston. So 2 students, this is cool. Once you start getting like 20, 100, 1,000, like it's really kind of a drag to have to like do this over and over again. Also, we'd like basically like a blueprint. Like students are basically the same pattern over and over again. A student has a name, they have an age, they have a hometown, right? And so essentially we're just filling in the information based on who the student is. They all follow the same basic pattern. So it would be nice to have a blueprint, something we could refer back to whenever we would like a new student. So instead of doing things like this, what we're going to do is we're going to create a class. I'm going to get rid of this code. And the keyword is class. We're going to say class student. All right, so a class is sort of like a reusable object. It's like a blueprint for a reusable object. So when we want to like build the house, we go to the blueprint first, because the blueprint has all the plans. It says the blueprint basically defines what the house is. How big is it? How many rooms? What goes where? The blueprint goes into detail about that. The classes, you could think of the same thing. A class is like a blueprint for a student. All right, well, how do we construct a student? Well, we're going to have a constructor, and the constructor will basically say, like, here's what I need in order for a student, like, to be. Like, here's the information I need for each student. So we're going to put name, age, and hometown. All right, so the constructor is a special function. All right, it will be run when we create a student. So we'll do that in a second. All right, once we make the constructor, we'll create a student. I'll show you how to do that. But you can think of it like this. When we create a student, what information do we need? Okay, we need the name, the age, and the hometown. Otherwise, like, that doesn't really make sense, right? The whole point of having a student is to have those 3 pieces of information. Then we're going to do this dot name equals name, this dot age equals age, and this dot hometown equals hometown. this keyword, this is a very difficult concept in JavaScript. Like even very devs with a lot of experience mess this up. So I'll explain what this means once we start creating students. So this is the minimum we need to create a student. So now when we want to create a student, what we can do is we can say let student1 equal, we're going to use this new keyword, student, and then we're going to put parentheses. And inside the parentheses, we can put name, age, and hometown in this order. Okay, we decided that this would be the order. So name would be James, age will be 19, hometown will be Boston. All right, so we've created a new student. What this line 9 is doing is saying, okay, cool. We have this class called student. I want you to create a new one for me. Okay, cool, I'll create a new one for you. Oh, I'd like you to run the constructor. Okay, the constructor has 3 arguments, name, age, and hometown. I'll need them. Okay, cool. Name comes first, then age, then hometown. So now this is sort of referencing itself. It's like self-referencing. It basically says this student. So in this context, this will mean student 1. We can create another student. Let student 2 equals new student. This guy's name is Bob. He's 22 and he is from Houston. So now, instead of doing all those objects, I just basically do new student and I can put in the information I need for each student and then I get an object. So student 1 and student 2 are both objects, meaning, for example, I could console.log student1.name. All right, so let's go ahead and run this. So I'm going to do node classes.js and notice how it comes out to be James. All right, so what is happening? Let's break it down. On line 9, I did new student. The first thing is name, the second thing is age, the third thing is hometown. So this string James got saved up to this variable name. Then I did this dot name equals name. So I mean that this student, his name is James. So that way each student can be different from one another. So this student 2, this student's name is Bob. So this is sort of referencing the object. It's the object referencing itself. It's kind of the easiest way to think about it. All right, again, this is not the complete explanation of the this keyword, but I'm trying to make it so that a newcomer could kind of grasp it. All right, so this, meaning this student's name is whatever name we passed in. Okay, common beginner mistake. The computer does not know what these things are. We just say name, age, and hometown because that makes sense for us humans. I could just as easily name this aardvark, zither, and saxophone. And if I use that, so this dot name equals aardvark, this dot name equals zither, and this dot hometown equals saxophone. All right, so obviously this is ridiculous, but if I ran this, see how it runs just the same? Okay, there's no difference. All right, so the constructor, the computer is not looking at oh, that's the name, that's the age. That doesn't make any, that has no meaning to the computer. All the computer says is that these are 3 variables. The first one's the first one you give me is this, the second one you give me is this. All right, so it doesn't have any sort of like semantic or meaning towards it. It just basically just makes them variables and assigns them in the order we tell it to. All right, so there's no magic there. Right, that's a common mistake that beginners make with constructors, thinking that there's some magic going on behind the scenes. There's not. All right, so this is the basics of a class. So a class allows us to create a blueprint for objects. So we can create classes for students, we can create classes for animals, you can have a class to represent electronics at a department store. You can do a class for whatever suits your fancy. All right, you use the class keyword, then the name of the class with a capital letter. All right, then you have squiggly brackets. And then we have a constructor. The constructor is a special function that runs every time you do new. So when we do this new keyword, we are running the constructor. So you think of like these new and the constructor kind of tied to the hip. When you do new, you're telling the computer, hey, I want to run the constructor. We do new student, which is the name of the class, in parentheses, and then inside we put the things that we need for the constructor. So in the class for student, we said we need name, age, and hometown. So after new student, you provide name, age, and hometown. Then inside the constructor, you set the name, the age, and the hometown. So this dot name equals name, this dot age equals age, etc. All right, and there you go. You've got yourself a brand new student, and then you can use dot notation like you normally do to get the values of that student. You create as many students as you'd like. They all have different names, different ages, and different hometowns. And this is a lot, neater and nicer than just doing objects like the way we learned in the last section. So this is a class, and you're going to use classes a lot, so try to practice this. Alright, so now we know the basics of classes, and let's kick it up a notch. So far, classes are just basically like objects that contain information, but they can also have functionality. We want to have our objects know things, so they know about their first name, their last name, and their age, or other properties, but they can also do things. Alright, so I've got this class student, and I have the constructor, which has a first name, a last name, and an age. Alright, so let's just say that in our app, that's what we need to know about the student. All right, we'd like a student to be able to introduce themselves. So they could be able to combine all these three things into a nice little greeting. All right, so what we can do is inside the scope of the class, so remember the class begins in this first curly brace and ends on the last curly brace. We can also add functions. Okay, so these functions are tied to the student class. So you could kind of think of it like when we were using functions that were related to strings, like for example to uppercase or to lowercase, those functions were related to the strings. So now we're going to have functions related to student. So let's have an introduce functions. We're just going to call it introduce with the E. And notice I didn't even need the function keyword. All I had to do was write the name of the function. I just called it introduce or method. I tend to switch up the usage of method and function. Functions that are related to classes are methods, so I'll try to keep that more consistent. But if you remember the function section, we basically wrote the name of the function. We had a parentheses and curly braces, right? So you don't need to put the actual function keyword in front of this. In fact, if you do, it will yell at you, right? Because this is related to the class. So all you gotta do is put the name, some parentheses, and then curly braces. All right, well, now we've got this introduce function, and what the introduce function is going to do is it's going to console.log, and we're going to use some string interpolation. So I'm going to use backticks. Hello, my name is, all right, and then we'll do this, first name, and then we'll do this dot last name, and I am this dot age, years old. All right, so this is just a basic greeting. So the student will be able to introduce themselves, give their first and last name, and be able to say how old they are. All right, notice I'm constantly using the this keyword so that it refers to the object itself. So this refers to the student. All right, so we'll say, okay, cool, what's this student's first name? It will depend on what we decide it is. So now students have this introduce method, but how do we actually use it? All right, let's create a new student. So let's let new student equals new student. And remember, this is the constructor. And if you ever get there's only three variables in our constructor, 3 parameters. So if you ever forget, you can always hover over the word student and it will tell you hey, this is the order that they come in, so that way you can remember. All right, so this guy's name is Johnny, and his last name is Bravo, and he is, 30 years old. All right, so we got Johnny Bravo, who's 30 years old. All right, now, how do we use this method introduce? Pretty simple. We're going to do new student dot introduce parentheses, because remember the parentheses say hey, go do this function. I want to run the function. Hit the start button and go for it. All right, so now we've got this introduce. So let's actually run our program. We're going to do node class methods.js. Hello, my name is Johnny Bravo, and I am 30 years old. All right, so it looks like it's working. So we create a new student. We were able to call the introduce method, and notice how it filled itself with the information about the student. So that way, if I have another student, so new student 2 equals new student. Let's say this guy is completely different. Let's call him Jack, and black, and I think he's 45, probably older. All right, and then we did do student 2.introduce. You'll notice that instead of putting out the stuff for Johnny Bravo, when we run it, it will instead put the information from this student. All right, so that's the kind of way I usually think about the this keyword. All right, so now we know how to put methods and attach them to a class. All you have to do is basically put the name of the method, and parentheses and squiggly braces. All right, we do not put the word function in front of it. All right, if we do, it will yell at us. Okay, we just have to put the name, parentheses, and squiggly brackets, and then inside we do what we normally do with a regular function. Functions that are attached to classes are called methods. All right, so this introduce is a method of the class student. Right, you can have as many methods as you'd like. We can have multiple methods. So like maybe like another method like get age. Okay, and then methods pretty much work like functions. They can return things. Like let's say you want, I don't know, return the person's age or whatever. You can use the return keyword, or you don't have to. Okay, they can take in parameters or they don't have to. So they work just like everything we explained in the function section will apply here to these methods. It's that the word method just basically says like, hey, this is a function that's directly attached to this class. All right, if you'd like to use a method, then all you have to do is just basically use dot, like the variable plus dot, and then you will call the method. So you do the name of the method plus parentheses. Don't forget the parentheses, right? That is this part is important. It's basically saying like, hey, go do the method, like actually go run it. All right, so now when we create a class of students, students will have first name, last name, and age, and students will also be able to introduce themselves. All right, so now we've got a real life object-oriented programming. We have an object of a student that has some related information bundled together in one object, and also it'll be able to do things with methods. So now we can start to create some really interesting programs. All right, let's kick things up a notch. So we understand classes, we understand their constructor and their methods, like we have this introduce method, and we have a constructor here. We can even create new students, right? We can use the class as a blueprint to create new students based on the pattern. So every student has a name, an age, and a hometown, and every student's able to introduce themselves. Now let's kind of combine our knowledge of objects and classes and all this good stuff with arrays, all right? Because that's going to be something you're going to do a lot. All right, let's create an array. Let's call it, like, let's say it's called student array. Let student array equal, and we'll just start off with like blank. All right, so you have a blank array like this, which is nothing in it. Now let's start adding these students to the array. So we could do student array dot push student 1. Now do the same thing for student 2. Student array dot push student 2. And student array dot push student 3. So now we can actually literally add these objects to an array. So then we can start doing some fun stuff with them. So I'm going to go ahead and console log it, and then I'm going to bring up the terminal. I'm going to do node arrays and objects.js. And as you can see, we've got an array because we see that you have this square brackets, and then we have each individual object. Notice how it has the type, which is student. Okay, what kind of thing is it? What kind of data? It's a student. And then you'll see the squiggly braces, the curly braces. That indicates this is an object. And then you notice how there are the properties of the object: name, age, and hometown. So this is an array of students. Okay, so if we have more than one student to deal with, which is probably going to be realistic, right? Like in a real application, a university has hundreds, if not thousands, of students. You're never going to just be really dealing with one. So having an array of students makes a lot of sense because you're going to have to deal with them as a large group. All right, so now we can actually use like push to actually like put students in the array. Like we actually like add students to this array. So every time we make a new student, we can add to the array, which is actually pretty exciting. We can even loop through the array with a for loop. Let's see how that works. All right, so I'm going to go ahead and comment this out for the moment, and then we're going to do a for loop. So we're going to do for int I equals 0, I is less than, oops, that's Java, so int I equals 0. So we don't have to use the int, just I equals 0. I is less than student array dot length, and if you remember length, that means how many things are in, how many elements are in this array, I plus plus. So what we're doing with this for loop is we're saying we would like to loop through everything in the array. Start with the first element. Remember, the first element is 0, right? In the array that was a 0 index, so the first element is going to be 0. Then I wanted to do it until the number of things in the array. So for example, student 1 will be at 0, student 2 will be at the first position, student 3 will be at the second position. All right, the length is going to be 3, so we'll be able to go through all of them. We'll go through 0, 1, and 2. All right, so as we loop through them, I want to take the student array, get me the element at I, and then I would like them to introduce themselves. There's a lot going on in this code from lines 22 through 24, so let's break it down again. I'm looping through the array. I'm starting at the 0th element, and I want to stop, okay, at the length. Remember, length is how many elements are there in the array. And then I++, which you should know from our for loops. Okay, cool. I like to take the student array, give me the student that's at position I. The reason I'm using the I here, the thing that's very confusing for beginners is like, what is I? I is always changing. Remember, the for loop happens over and over and over again, right? So at first, I will be 0. Then I will be 1. Then I will be 2. So this will always grab a different student at a different position. Remember, this bracket after an array means go grab me the thing at this index. Then once it's grabbed the thing at the index, run the introduce method. All right, I think once I run this, it'll be a little bit clearer if it's still not clear to you. So we'll just go ahead and run it. Hello, my name is Joe Everybody, Nathan Smith, Angelina Jolie, and notice how for each of the students in the array, it did that introduce method. Okay, remember that introduce method would be hello, my name is, etc. All right, so this for loop, we loop through the array of all the students, and for each student, we had them run the introduce method. Pretty cool, right? So now we have a whole bunch of students with different names and different ages and different hometowns, and we can put them in an array. We can loop through the array and do something. All right, so if you're still not clear again what this is, the student array I, that's probably the hardest part for a beginner to get, then I think you need to review the for loops, okay, because remember, I changes. So I'm going to console.log I currently is plus I. So that way you can kind of see that it's like incrementing. So I'm going to run it again. I is currently 0. Take the student array, give me the element, the 0th element, and then run the introduce method. This is what happens. All right, next loop. All right, so we get down here, we get to line 25. The for loop is not ended, so it goes back up to line 22. Okay, I is now 1. This I++ says when you get to the end of the loop, take I and bump it up by 1. So once we get back to line 22, line 23 says I is currently 1. All right, cool. Give me the student at index 1 and then run the introduce method, and that's what happens here. All right, and then it does it over and over and over again. So we can add new students. So for example, I can do let student 4 equals new student, and I'll call this Steve Rogers, who is 120 years old or whatever it is. And he is from, I don't know, Philly, or I think it was actually Manhattan. I don't remember. So student array dot push student 4. Now look how flexible our code is. So I added another student, and then I'm going to run it again, and now you can see that I have Steve Rogers now. So this for loop, it doesn't matter how many different elements there are in this array, I'm able to loop through them, and I'm able to call the introduce method for each one of them. All right, so now we can deal with multiple students, which is a far more realistic situation. Hi there, and thanks for watching. If you like the content of this video, please like and subscribe.